Rathod sir, good morning.
Good morning, sir. Good morning. Renuka madam.
Yes, sir. Very good morning to everyone present here. I, Renuka Pawar, wholeheartedly welcome you all on behalf of the organizing committee at Bharti Vidya Bhavan, Sardar Patel Institute of Technology on 9th day of AICT sponsored 2-week online faculty development program on artificial intelligence and machine learning. I take this privilege to warmly welcome Dr. Mayank Singh. He is working as an assistant professor in the Department of Computer Science and Engineering at the Indian Institute of Technology, Gandhinagar. He joined IIT GN as assistant research professor in July 2018. Currently, he is leading the Computational Linguistic and Complex Social Network Group, that is LINGO. His primary research interests include natural language processing, text mining, information retrieval, and involving large-scale networks. He is highly interested in application areas such as information extraction, both text and visual, from scientific articles, curating and analyzing social media text in resource-constrained Indian languages, citation networks, and Twitter, WhatsApp user interaction network. He has more than 25 publications in the reputed journal and conference. He has received many awards, such as Gandhian Young in Technology Innovation in 2017, then Best Paper Award in International Conference on STEAM. Then he has also received Early Career Research Award from SERB, that is Science and Engineering Research Board. He has worked on various sponsored projects from the various agencies like National Council of Science Museums, Ministry of Culture, India, and Science and Engineering Research Board. I thank Professor Surendra Singh Rathod, the coordinator and the backbone of this workshop, for getting the versatile speaker on board. So thank you very much, sir. May I request Dr. Mayank Singh to take over and start the session.
Thank you, Renuka ji, and thanks Dr. Surendra for inviting me for this talk. So, is everyone able to hear me?
Yes, sir.
Okay, okay, and you can. Okay, so you have given me the permission to share my screen also. Thanks for that. Yes, so I hope you can see my screen. The first page of
Yes, sir.
my presentation, it shows natural language processing. We are able to see. Okay, okay. Let's do some check. Okay, thanks a lot. Yes. Okay. So today I shall be mostly talking about the very interesting topic in computer science, and that's called natural language processing. So but before I go ahead with the topic and I introduce you with what I mean by natural language processing, so how many of you are from computer science, or like you are like you're teaching in allied computer science? Also, that's also fine. So how many of you are from computer science? Almost. So is it the case that almost everyone is from computer science, or people are from some other branches of
No,
science also?
no, sir. There is a mixed population. Around 70
Great.
participants are there, but in every session, around 50 participants join, 40 to 50. And out of 40 to 50, almost 25 to 30 are from core computer science and information technology. But there are many who are from electronics, telecommunication, and one or two participants from management and mechanical engineering also.
Okay, okay, okay. That's great. That's great. And is everyone teaching like in one of the institutes somewhere in India,
No,
or
all
there?
are faculty members. All are faculty members across the
Oh,
nation.
all are
But
faculty.
even though they are from mechanical or management, but they are teachers in the same
Okay.
domain.
Okay, that's very good. That's very good. So, so I will try to keep talk according to that. That's why I thought maybe I should understand the audience. Right. Okay. Okay. So, so in today's talk, I will be mostly talking about some applications of natural language processing, some techniques that we are using in natural language processing. Along with that, we will see like as a teacher, if suppose this is the first time you are planning to teach natural language processing, so what could be possible for this course and how you can evaluate this course, right? And then maybe some more thoughts about what can be some of the reference books for this course and so on and so forth. So we'll go through almost with the applications, the limitations, the challenges, right? And then a course proposal and so on and so forth. So we'll see all this in next almost 3 hours. Okay. So, but before I start, just let me know that how many of you have heard natural language processing before, or you have done some kind of natural language processing before. Maybe you can just say yes, or you can raise your hand. Okay, okay. Few people have, yeah, yeah. So I can see, yes, yes. So I can see some people have done some very basic kind of natural language processing, but not all of you have a kind of conversation with what I mean by natural language processing. Okay, that's good. So that makes my life easier because then I can start from the very beginning. Okay, so if I say that what is text, right? So what do I mean by text? So by text I mean everything which is present in the form of something which has been which like every all the content which is present in the form of a written, like present in the form of a written text, that is called text, right? So like, and where it is present. So right now, whatever social you talk about, whatever social media platforms you talk about, you will find text almost everywhere. You will find text in Facebook, you will find text in Google, right? And you will find a lot of text in Twitter, which is easily like crawlable. You can get this text. There is a lot of text in the form of like LinkedIn is one of the platforms. There's a lot of text present in platforms like discussion platforms like Quora, right? Apart from it, what are the other platforms you are aware about where you will find a lot of text? People are kind of discussing with each other. They are generating a lot of text in different languages. Are you aware about some kind of such kind of other platforms? Social media platforms. Let's talk just about social media platforms. Do you think that Amazon can come here? People are talking something about products. Are people talking about products? Are people talking about items? Are they giving you some kind of reviews? So Amazon could come here, Flipkart could come here, right? People are again talking a lot about different things. There are a lot of questions also you will find in Flipkart. You will find a lot of like question answers in Flipkart, whether this product is good or not, whether this product has this warranty or not, right? How much is the actual warranty or not? How much is the support for this product and so on and so forth, right? So there is a lot of discussions happening. Even though Flipkart is not a social media website, but you will see a huge amount of discussions happening on Flipkart. It's the case with Amazon, right? So you just log into Amazon.in and you will find that a lot of people are kind of talking about, so a lot of people are kind of giving reviews to the product. In addition to that, there are a lot of people who are kind of posting questions, and users who have used that product, they are kind of giving replies to those questions, right? So that's again kind of like generating a lot of text, which can be used in some way. Okay, so that means text is almost everywhere, right? So whatever domain we talk about, whether this is some kind of online retail market like Flipkart, Amazon, or Myntra, right? All these are different like online retail markets, or there are some discussion forums like Quora is one of the discussion forum. Another discussion forum could be Stack Overflow, right? That also contains a lot of text being like being actively written, right? Or it could be just some kind of messenger services, like you have the WhatsApp, you have Facebook Messenger, right? So all these are different kind of messenger services. They also contain a lot of text. Or it could be like very popular platforms, like social media platforms, like you have Facebook, right? You have Instagram. So Instagram again has a huge amount of text that people are trying to like generate in this platform. That means there is a huge amount of text, right? And we have to process this text, right? So there is a huge amount of text which is being generated every day, and we have to do something with this text, right? Now let us try to see what other kind of things are also present, where like you will see a lot of text being generated, and then we will see why it is kind of very difficult to process this kind of text. Okay, so not just these social media handles, right? We as a like we all of us are kind of teaching, right? All of us are kind of doing some kind of very simple kind of research also, right? So it's not just the text is present in the form of social media text only, right? So text is also present in the form of like research papers. Text is present in the form of scientific documents. So huge amount of scientific documents are being written almost every day, right? There are huge amount of patent articles which are being filed every day. People are writing books, people are writing review articles, people are writing magazines, they are writing blogs. Then there are a lot of crowdsourced platforms like GitHub, Stack Overflow, Orchid, and so on and so forth. So everywhere, whatever like kind of these kind of like platforms you see, these kind of articles you see, papers, news articles, and all these are kind of some of the examples where text is present. Right. So do you know at what rate scientific documents are being, the volume of scientific documents is increasing? Is it linear? Is it exponential? Is it decreasing? Is it power law? What do you think based on your intuition? The rate at which the volume of scientific documents is increasing? It's exponential. Yes, right. So just try to understand the problem of generation itself, right? So huge amount of documents are being generated at an exponential rate, and we have to understand. We have to. So suppose I came up with a problem, right? I came up with a problem. Suppose I want to work on some kind of sentiment analysis, right? I will describe what I mean by sentiment analysis, and then you wanted to do a very simple literature search on all possible papers which were written about sentiment analysis. So this is again a very difficult task. There are kind of what you will find is just by searching in Google with the term sentiment analysis, you will get more than 1,000 papers. So are you going to read these 1,000 papers? No, right? You're not going to read that, because if you start reading 1,000 papers, then when you start doing your research, so that's kind of a very impossible task. So one of the very simple tasks would be, given these 1,000 papers, can I prune these 1,000 papers to just top 10 papers? That itself is a very interesting task. If I read these top 10 papers, I will be done and I don't have to read the rest of the 990 papers. Other task would be that now suppose I prune down my entire candidate list of 1,000 papers to 10. Can I create a summary of sentiment analysis from these 10 papers itself, so that we don't even have to read these 10 papers individually? Just a small summary can help us to understand the entire like history of sentiment analysis for a given like problem, right? So the second part of this is called summarization. First part of this is called some kind of filtering, right? Some kind of filtering you are doing, and then on that filtered set you are doing some kind of summarization, right? So again, these two are natural language processing tasks, right? We'll describe all these natural language processing tasks in the meanwhile. Okay, okay. Apart from it, do you think other like other sources where you will find a huge amount of text? I showed you two possibilities of like getting this text. Do you think some other kind of other types of things where you will find a lot of text? Anyone? What about YouTube? Will you find some text in YouTube also? Any other like online medium that you think where you'll find some text, which we have not at least covered in this previous two slides? Blogs, exactly. You will find a lot of blogs. You will find a lot of blogs, and blogs will contain a huge amount of data. So, do you know any blogging platform? Do you know any blogging platform where you'll find a lot of such kind of like blogs? But yes, WordPress is one of them. Yes, yes. Right. So WordPress could be one of them. There are many such blogs. So even Google blogs are kind of very popular these days. Medium blogs are kind of very popular. So people are writing blogs in Blogspot. Yes, Blogspot is one of them. Medium blogs are again very popular these days. Right. So these are kind of like different. So these are kind of like different platforms where you'll find a huge amount of text. Right. So at least whenever yeah, GitHub is one of them. Exactly, GitHub is one of them. Correct. Yes. So if you see here, like in whatever natural language processing task that we want to do is, the basic requirement is that are we going to have some data to process or not, right? So at least that is not the problem these days, that you have a huge amount of data to process, right? But again, there are some very critical issues which we will look into this, like in this 1.5 hour at least. Like what are those critical issues because of which we are kind of not, it's kind of not very easy to process this text. Okay, let us try to see that thing. So what does this slide says is, again, let me, yeah, yeah. So what does this slide says is, there is a huge diversity of languages worldwide, right? So, do you know how many languages are almost, how many total languages are being spoken today worldwide? Total number of languages. So the count would be like if it's kind of like the languages which are being spoken by at least 1,000 people, right? So those will be counted here. So how many total number of languages which are being spoken today worldwide? Any guesses here? In thousands, in lakhs, 10,000, or so and so? Any guesses? In thousands. In thousands. So some yeah. So Miss Renuka is saying that in thousands. Yes. So that's correct also. Yes, that's correct also. So there are around 7,111 languages which are being spoken, and these are kind of, we should always call them as popular languages, right? Because they are being spoken by at least 1,000 people. Okay, so there are around 7,000 languages which are being spoken worldwide. But can we understand majority of this word data? What do you think? So there are kind of 7,000 languages. People are trying to conversate in these 7,000 languages. How many languages do we know among these 7,000 languages? What percentage? Any guesses here? Out of 100%, what percentage of data do you think that you understand globally? Not even 1%. Okay, okay, not even 1%. Okay, let's try to see. Yeah, very few. Let's try to see that. Okay, so this is the percentage of world population, right? If you see the first, the highest, the best, the topmost language, the most spoken language is Mandarin, Chinese, right? It's Mandarin, and almost 14% of the world population speaks this language. So almost 14% of the population speaks Mandarin. Then the second most popular language is Spanish. Then the third most is 5.52 English, fourth is Hindi 4.46. Then you have Arabic, Portuguese, Bengali, Russian, Japanese, Punjabi, and then you will go down. You will find Marathi, you will find Gujarati, and so on and so forth. Right. So other Indian languages will come after the rank 10. Okay. So just given this small table, what do you think in language do you know? What percentage of people, what percentage of world population you come in? At least you know English, right? So you come here, you know Hindi. Some of you might know Hindi, right? So you might also become in this population. So 4.46. Some of you, I don't know, like if you know Bengali or not. Some of you might know Punjabi also. So almost 10% of the population. So it's kind of like almost you can understand data which is being generated by almost 10% of the population of the global population. Rest 90% of the data which is being generated by the rest of the global population you cannot understand. So that's kind of a very simple like analysis that we can do here. So you can only understand the data being generated by 10% of the population. Above that, you cannot understand the data because you do not have the knowledge of their native languages, what people are kind of talking about in what language, right? So even though it seems as if you have a huge amount of data and you can understand everything, but actually that is not the case. Fine. So that is actually not the case. You cannot understand more than 10% of the total population data. Okay. So now let us try to see this from the perspective of India. So overall, we can see that we don't know the entire global data being generated. Okay. What about India? So within India also, there is a huge diversity of languages, right? So maybe let us try to see, can we understand at least the majority of the India's data? Even that would be sufficient. At least we want to do some kind of India specific studies. Okay. So in India, if you see, as per 2011 consensus, there were more than 1650 languages. Within India itself, you will find more than 1650 languages, right? This is again older consensus around which happened at around like 2011. Fine. And among these 1650 languages, Hindi is the prominent one, which is being spoken by 57% of people, right? English comes in the second stage or like the second rank. It is being spoken by 10.6% people. Bengali, Marathi, and then Telugu follows English. Fine. So now, what do you think? How much Indian data you can understand, at least from here? Suppose you are speaking Hindi. So if suppose you are speaking Hindi and so you can at least understand almost 60% of the data. Like 60% of the data generated by the population, right? So who can speak Hindi, isn't it? But still, if you just know Hindi, you cannot understand almost 40%, like 40% of the population. Because whatever they are speaking, they are speaking some other native language, right? So it's not that we cannot understand the global data. It's also the case that it is sometimes even difficult to understand within India also what people are kind of conversating with each other because we do not have the knowledge of different native languages. Okay, so before I move to the next slide, please let me know over the chat that do you have any difficulty or like do you have any comments about the things that I have covered till.
No, sir, no.
No, okay, okay, that's great. So I will go to the next slide then. Yeah. So now let us try to understand what are the basic goals of natural language processing. We have seen at least few things that there's a huge amount of data which is available, right? But we do not have capability to understand this huge amount of data. We don't have the capability because we don't know all languages which are being spoken in the world. Right? We don't know all the languages which are even spoken in within India. Right. So even understanding the Indian data itself is a huge, and it's a kind of very challenging task. Okay, so this is what we have covered till now. Now let us try to understand that what are the goals of natural language processing. Okay, suppose you are given a sentence and the sentence says "Tu bui un Coca-Cola." Right, so this is a French sentence and it says "Tu bui un Coca-Cola." So what do you mean? What do you? So suppose you do not know French, right? I'm not asking this question to people who know French. I'm asking to the people who do not know French. What do you think would be the corresponding English translation of this French sentence? You can type in here. What do you think would be the English translation for this sentence? Do not worry, even if you are wrong. It is okay. Yeah. No worries if you're wrong, right? I'm not going to run behind you. It's okay if you're wrong. So Pallavi is saying, I like Coca-Cola. Dr. Surendra is saying, I drink Coca-Cola. Sonal is saying, you want Coca-Cola. Okay, that's very good. That's very good. Any other options? So we have at least three options. We need one more option. Okay. So meanwhile you are writing here at least one thing which is kind of very clear. So which is known to everyone that the term Coca-Cola is kind of very clear, right? So Dhananjay is saying you buy Coca-Cola. Okay, that's very good. So we have four options. I like Coca-Cola, I drink Coca-Cola, you want Coca-Cola, you buy Coca-Cola. That looks very good. Okay. So uh, one thing which is kind of very clear here that the term Coca-Cola is clear to everyone. Right, the term Coca-Cola is clear to everyone. And by Coca-Cola, I mean that this is some kind of drink. Right. So why do we know the term Coca-Cola? Because in English, because in Hindi and whatever language we use, the Coca-Cola is some drink that we refer to. Right. So that is at least which is very kind of clear to us that Coca-Cola, we are referring to a drink called Coca-Cola, which is popular. Right. What are the other things which we can infer from this sentence? Okay. So Coca-Cola is a drink, we know. Then there is a word called TU2, right? So do you think we can convert this to some word in Hindi or some word in English? Do not drink Coca-Cola. Yes, that could be one of the possibilities. So one of the ways in which, like as a human, we try to infer things, right? So we are doing this as a perspective of a human, right? So what we do is whenever we are given a sentence in some unknown language, right? So suppose we do not know. So this was an unknown language. What we try to do, we try to infer some of the words which are kind of look similar and they are also present in our native language, isn't it? So among all these four words, at least a word Coca-Cola we are aware about, right? So we know that Coca-Cola is a drink. The rest of the things, tu, bui, un, would be specific to this particular drink. I don't know what it means. Okay, now that's one thing. In the second step, we will try to guess more, right? So one possibility is let us try to see the word tu, right? So two can be to some extent can be like mapped to a English word you, right? So maybe it might be so it might be possible that this French sentence is saying something about you bui un Coca-Cola, right? So where two is kind of mapped to English word you. Right? Bui, I don't know what it means. Un, so again if you say un can be related to a word a, right? Because there are again some words in English where you use un. Okay, so let us try to see this. You drink a Coca-Cola. That's the correct translation of it. think no one has given me the correct answer, but you have tried to infer. You have tried to infer based on your understanding of English, right? Based on your understanding of English, you first of all try to look for some known keyword, and then you try to create a sentence around that keyword. Isn't it? This is what the thought process you have involved in your mind. Let me know if I'm wrong somewhere. Okay, that's very good. Yeah, that's how that's the similar thing we want to teach our computer also, right? So as a computer, so this is something that we have done as a human. Right? As a human, it is kind of easy to come up with a translation, right? So even if it is not correct, at least very similar translation. But same thing, we have to make our system to learn, our computer to learn, right? And that's where the challenge comes, right? So as a human, we try to understand a foreign language using some known keywords. Right? That's the main tagline of this entire experiment. So we try to understand this foreign language by using some keywords, right? And we want to make our system as human. We want to make our systems as human so that it can understand these kind of inferences. It is able to make all these kind of inferences that yes, Coca-Cola is in my memory. I know the system knows, right? The system is thinking that yes, I know Coca-Cola. Coca-Cola is some kind of drink, and maybe two can correspond to U or un can correspond to A, and based on this, I can come up with some possible translation, even though I don't know the meaning of boy, right? Even though I don't actually know the meaning of two or un. Okay, so that's where NLP comes into picture. Right, that's where this we talk about like the main goals of natural language processing. What do we do in natural language processing? Okay, so in natural language processing, we train systems so that we have a deep understanding of broad language constructs. What this line says is that we try to make our program, we try to make our system understand the broad language construct. So broad language construct means the grammar of the language, right? So it means the grammar of the language. So we make understand our system to the of the language so that it understands the grammar of language. Along with the grammar, we also want our system to understand the meaning of the word. Right. So grammar is fine, right? Grammar will help us to structure the sentence, but meaning is also very important. Just structuring is not enough, right? So we also want to make our language representative of a real language, right? Whatever the system is trying to understand, it should understand as if it is not the system, it is a human, isn't it? So that means the deep understanding of broad language construct. It is not just the grammar, it is also the semantics, the meaning of the different words and the sentence as a whole. Okay. Achieve human-like comprehension of text and language, right? So if we can make our system understand these language constructs, it can achieve a human-like comprehension of text and language. As a human, we understand all these languages. Same way, we can make our system also understand these languages. Okay, and the final goal of NLP is make computer systems to understand, draw inferences from, summarize, translate, generate accurate and natural human text and language. Fine. So it is not just that the system has to understand the language. The system also has to generate accurate and natural human-like text and language, right? So it has also to generate a text which thinks as if it has not been generated from a computer. It has not been generated by a program. Right? It has been generated by some human. If we can construct such kind of systems, then we are almost kind of done. And that's where the challenge is kind of coming these days. Right? Do you agree? Like, do you agree that still, even though there is a huge amount of research going on in like generating natural language text by programs, but still there is a large amount of scope so that we can improve on it. We'll show some results, but just wanted to like see if you have seen such kind of system where the text has been generated by some machine. and you think that text is not very appropriate, it can be made better. Okay, okay. So let us try to see some examples, and then things will be much more easier. Okay, so we have said that maybe we want to make our systems behave like humans. We want to make our systems behave like humans, where they can understand the natural language text and they can generate also the natural language text, right? If we are kind of successful in doing this task, then we are kind of done, right? And we will try to do all this using some natural language techniques, right? We'll talk about all these techniques in a meanwhile. Okay, so let us first of all try to see some of the applications of natural language processing. And one of the most popular, one of the most discussed application is language translation. So, how many of you have seen this system, the system that I'm showing here in the presentation? Have you seen this system before? Yeah, seen this system. Apeksha has seen this. Yeah, Manoj has seen this system before. So, what is this system called? Yeah, Sonal and Energies has also seen. Yeah, yeah, that's very good. So, what is this system called? This is a Google Translate. Exactly. This is a Google Translate, right? So, it's not that we only have one translation system. There are many more translation systems. So, for example, you have a Google Translator, you have a Bing Translator also, you have Microsoft Translator. So, there are many popular translators which are right now available, and you can use any one of them. But Google Translator is again kind of free, and it is again it is kind of doing very good than other set of translators. Okay, so what I had done is I had given a text here. I had given a text here as an input to the translator, and I have selected the input text language as English, right? And as an output, I want this English sentence to be converted to Hindi. I hope some of you can at least understand Hindi, right? So to just appreciate what I want to say. Okay. So I had given an input in an English, like I had inputted a sentence in English, and what I want is I want the system to translate this English sentence into Hindi. Fine. Okay. So the next sentence was, let's go out for a date. Let's go out for a date. And the system has translated this English sentence into Hindi. Fine. And after this translation, the Hindi output is चलो एक तारीख के लिए बाहर जाओ. Do you think the translation is correct? How many of you think that the translation is correct? The input was let's go out for a date, and the output is चलो एक तारीख के लिए बाहर जाओ. What should have been the correct translation here? You can speak also if you want. What should have been the correct translation here? Okay, so it's okay if if you do not want to speak, that's okay. But at least we are sure that this is not the correct translation. That's not correct, right? So where is the problem here? Where is the problem? Do you think in that is present in the output sentence? What is the problem?
I think it's date.
Date, right? Date. Yes, yes. So the problem here is date. The translator, Google Translator, was not able to understand in what context the word date has been used here. Isn't it? By context, I mean the surrounding word. The surrounding, right? So the surrounding of date are talking about let's go out for a date, right? It's not the calendar date we are talking about, right? So here, the context of date is about some event. It's not the calendar date that the context is talking about, right? So you go out for some event, some event, any event like which corresponds to date. Okay, and that's why this is incorrect. चलो एक तारीख के लिए बाहर जाओ. That's not correct. So date is not equivalent to तारीख here. Date is equivalent to some other event where people go out, they eat some food, they watch some movies, and so on, so something like that, right? So why do I want to show you this like example is that even if I talk about very popular translation systems, like very popular, widely used translation systems, still they are not perfect. Where like it still cannot perfect, and you can see it using a very simple example. It's not a very complex example where you have like 100 words in the sentence. It's just a very simple sentence, and it is failing here, right? You can come up with many such kind of sentences. You can always come up with many such kind of sentences where it is kind of failing. So that shows that even though there is a huge amount of research happening in natural language processing, there is a huge amount of scope also where you can improve upon. One of the reasons is that majority of the work that you will find in by the teams of Google, Microsoft, Amazon, and so on and so forth, they are kind of doing this work for English language or languages which are being spoken in Europe, right? So either European languages or Indian, like the English language. They are not mostly talking about the Asian languages till so far, right? And that's where the opportunity comes into. As Indians, like as Asian, we are generating a huge amount of data, but we do not have good amount of tools to process these languages. Right? We do not have good tools. We do not have good architectures to process this kind of language. Okay, fine. I hope this example is kind of clear to you guys. Okay. So another example. This is kind of a more difficult example for the computer to. Here, this time I just inverse the input and output, right? So this time that input text was Hindi and the output text from the system should be in English. And the input text here, the Hindi sentence, this came from a Hindi song, Hindi movie song, right? Tere mere haath mein tera haath ho, sari jannate mere saath ho. Again, this seems to be very simple. Yes, ideally it is very simple, right? But again, like it has more number of words, so we can call it as a complex sentence. Okay, just look at the English translation and tell me if it is the correct translation of the Hindi sentence. Right. So that's where the limitation of these systems are. Yeah. So Manoj is saying that no, it's word to word translation. Exactly. So the problem with all these kind of translation systems is they are still trying to perform translation word by word, right? They will take one word, they will translate it to other words. They will take one word, they will translate it to other words, and so on and so forth. Actually, what it should have been happened that they have chosen a word, they have looked into its context before and after, right? And based on that, they should take the decision. That should be the ideal case, right? But again, there are some systems which do like that, but they are not very popular systems. So the popular systems are they do the translation still in a very basic way. Yeah, but heaven is missing. But heaven is missing if it was word to word translation. Yes, yes. So the word Jannate is Jannat a Hindi word? Urdu word, right? So yeah, so you understood one thing that what I had done is I had specifically mentioned that my input sentence is in Hindi, right? So it will look into the Hindi dictionary. It will look into the Hindi dictionary. It won't look into the other dictionaries. So the word Jannat, if you talk about, it's not present in the Hindi dictionary actually. That's why if you are specifying that my sentence is in Hindi, it is not going to look into other dictionaries, and if there is some out of vocabulary word, that won't get converted. Okay, I hope things are now clear, right? So again, this is again a problem. I will describe later that if your input sentence has multiple languages, right? So in this case, we have like kind of multiple languages embedded together in the sentence. Some words are coming from Hindi, some words are coming from English. It confuses the system. It confuses the system. It doesn't know what to do with this out of vocabulary word. Okay, we'll describe this problem later part of this session. But I hope the examples are kind of clear to you. Let me know if you have doubts there. Okay, okay, okay. So let's move to the next slide. Okay, so this is still about language translation only, right? We are seeing two examples from Google Translator, right? Where it was not performing good. It does perform good in many of the cases, but equally it doesn't perform in many other cases. Okay. You said that one problem with the language translation is that sometimes it is not even easy for humans also to perform the language translation. Right? So sometimes it is not even easy for the humans to do the translation. For example, it happened like multiple times when some companies who were kind of popular in English speaking countries, they tried to open their market in other countries where English is not the prominent language. So, for example, Pepsi, Pepsi is what? Pepsi is US based company, right? Pepsi is a US based company, and their market was mostly in those countries. Like when that, like at the time when I was talking, I will be talking about this example. So at that time, their major market was in English speaking countries or countries where people know English very well. Right. So whatever slogans, whatever logo they create, that was easier for them to create because they know English, people know English, right? So it's kind of like very well, it was done very well. Right. Now what happened is they wanted to enter into the Chinese market, right? So they made a slogan for the Chinese market, and the slogan was in English, "Come alive with the Pepsi generation." Right. So they created this slogan, "Come alive with the Pepsi generation" in English. This slogan they thought that maybe they will convert back into the Chinese. Okay. When they will launch themselves in the Chinese market. Okay. So the same slogan they converted this into the Chinese. Some of its representatives have converted this into Chinese. Right. And when this was converted into Chinese, right. And the Chinese slogan was, if you can convert that Chinese slogan into English, the meaning of that sentence was completely jeopardized. Right. Now the meaning was, Pepsi brings your relatives back from the dead. So the actual English sentence was, "Come alive with the Pepsi generation." They converted that to Chinese, and while they were trying to convert into Chinese, because they don't have very good idea about like how about the context of the Chinese language, they have just jeopardized the translation, and the translated example becomes, "Pepsi brings your relatives back from the dead." Right. And that's where the limitations of language translation come, right? So it is sometimes not even easy for the humans to even understand. Right. So even humans to understand and come up with a translation. So okay, that's okay with the Pepsi. Same thing happened with KFC also. So KFC again is a prominent company in English-speaking countries as well as like countries where people can understand English, right? Their slogan was "finger licking good." So their product was very good. It was kind of finger licking good, right? They converted into Chinese, which meant "we will eat your fingers off." Very very strange translation. We will eat your fingers off, right? And it created a huge backlash for KFC in China at the time of its launch. Right. So again, if I just reiterate once, sometimes it's not easy for systems to do a good language translation, but equally it is not even easy for humans to do the correct translation sometimes because you don't know the context in which a particular language like is being spoken, right? So for example, if there is some sentence in English and you want to convert it into Hindi, you should know that what are the different words in Hindi, what specific words should be like translated this English sentence to. Right. So that's how things work in any other translation, right? Same. So suppose like you are speaking Hindi and you suppose you are from Bihar, right? You are speaking a very different type of Hindi. You are from UP, you are speaking a very different type of Hindi. Same thing if you move to Gujarat, right? You are talking about the same language, right? Hindi. But again, the way you speak Hindi is kind of very different, isn't it? So that's where this regional differences, the contextual change, all these things comes, and you have to translate your sentences accordingly. If it is not correct, you might feel some problem. Okay, okay, thank you. Yes. So okay, so let us see some more examples. So these are kind of like pictorial examples. Okay, so there was something written in Chinese. There was something written in Chinese, and when it was translated to English, it became poisonous and evil rubbish. So the actual meaning of this sentence, I remember it was put your garbage here, something like that, right? And when they converted it into this English, it became poisonous and evil rubbish. So rubbish cannot be poisonous and like at least the rubbish cannot be evil. The rubbish cannot be evil. It can be poisonous, but it cannot be rubbish, evil. Okay. Similarly, there are many more such examples where it was saying that so it was saying something else, but the translation is saying something else, right? So it shows that the translation is saying sleep and fall down carefully. But actually, the Chinese text was please like walk carefully, otherwise you will slip, something like that, right? So this English translation has completely changed the meaning of the Chinese sentence. Again, the idea is these all translations have been created by some human. Which suppose maybe this was the translation, right? People who have created this translation do not know about English, right? They have just converted, they have just used some kind of dictionary and converted Chinese to English. Same thing is happening here also. Okay, so that's what about that is all about translations. Why translation is difficult for humans? Why translation is difficult for systems, right? And then there are a lot of opportunities also here to come up with new and new systems. Okay, now let us talk another application of natural language processing, and this is kind of very popular application which you at least you yourself have experienced a lot number of times, right? And this is called query recommendation in search engine. So you are kind of, so what interface is this? What interface is this? I'm showing in my slide. So what website is this? Whatever I'm showing in my slide, it is Google search, right? Google search where I am giving some text as an input. So for example, here my input text is Dhoni is, right. I have to write something, but I stopped after just writing Dhoni is. And then what Google is trying to do is Google is trying to recommend me some of the popular things that I could have typed here. So I just typed Dhoni is, and then maybe Google is trying to recommend me that do you want to search for Dhoni is back from which state, Dhoni is back, Dhoni is in this team, Dhoni is retiring, Dhoni is there, Dhoni is photo, Dhoni is legend, Dhoni is injured, Dhoni is age. Fine. So this is again a very simple example of what natural language processing, where like the system is kind of trying to recommend you some popular queries based on whatever you have given as an input, right? So you don't have to type the entire thing if something is already present, right? You type something more, you type one more word, the entire recommendation will change. The new set of recommendations will come, right, based on whatever you have typed. So this is again a very simple example of natural language processing, which is happening at the back end. Okay, that was the second application of natural language processing. This is the third application of the natural language processing, and again, it seems to be very simple. It says spelling correction, right? So, have you seen this thing before? Does Google helps you to correct your spelling? Right. Yes. Yes. So I hope you have seen this thing before also. If you're typing some incorrect spelling in your Google search bar, it will try to search, or it will at least tell you that your spelling is incorrect, and it will suggest you that this could be a possible correct spelling of whatever like you are trying to type, right? And based on that, whether you want to search for the correct spelling, whether you want to go ahead with whatever you have spelled, right? Based on that, it will show you the result. Okay, again, what is this? What is this again? One of the example of natural language processing text. Okay, so this is about processing the natural language text. Okay, why do you think spelling correction is a challenging problem? Any idea why do you think spelling correction is a challenging problem? It seems to be very simple problem, right? You have a huge, suppose you have a huge vocabulary of all possible words in English, right? If I'm typing something and I made a mistake, right? So how will the system detect that I have made a mistake? It will check each word if that is word is present in my vocabulary. If that word is not present in my vocabulary, it will show that yes, it is a spelling mistake. Why do you think it is a challenging task? Okay, in different languages, the spellings can be different. Yes, that is true. Yes, that is true. Yes. Within the same language also. Suppose I'm not mixing different languages. Suppose I'm just talking about English. Why spelling correction in English is a difficult task? You are saying that there is a huge number of words. Okay, we have a huge number of words. Okay, so what if we can? So how many words do you think you have in English? Unique number of words. It's not much. Suppose it is in lakhs, not more than lakhs. Unique number of words, isn't it? And you just store it in some kind of hash function. It won't take even MB of space to store all this and then to search for them. Just store them in some Python dictionary. Look for these words in the Python dictionary. So it will take a constant time to search for given word. So that's not a problem actually. So the problem actually is with a word need to understand the context. Yes, that is important. Yes. So yes. So that's where I want to discuss it. That suppose I have written a word, right, and the spelling of that word is correct. Right. If I want to find a corresponding word in my vocabulary, that word is present, right? But what has happened is I have actually written the incorrect word, right? So for example, there is a word peace, P-E-A-C-E. Another word which is very similar to pieces, P-I-E-C-E. It might happen while I was searching, I replaced one word with the other one, right? So the system should try to, the system should be created such that it should tell me you have made a spelling mistake here, right? Even though the incorrect word is present in my vocabulary, and that's where the challenge will come. That's where the challenge will come, right? So that's the most challenging part of the spelling correction in such real world system. So we need to think about like all these kind of vocabulary present spelling things, right? So the word where you have made the mistake, that is actually present in your vocabulary, but the system should look into the context around that word, and then it should understand that yes, this word is not correct. There has been some mistake which has been made here. Okay, fine. I hope these two again these two applications are kind of clear, and you are also clear about the challenges there. Okay, now this is the fourth application of natural language processing. Can you read paragraph 1? Then things will be much easier to make you understand. Yes. So the idea, the task here is that suppose you are given these kind of paragraphs. Right? What you are given, so your system has been given these type of paragraphs as an input, right? And your system has to automatically construct this kind of table, right? So let me rephrase this. What I mean to say is the system has been given a paragraph as an input, and it has to construct these kind of tables. Now let us try to understand these tables. So by table, so each table will have some rows and columns. Let us try to read these columns. So here the columns represents different kind of entities. So the first column here represents a person entity. That is name of some person. The second column here represents the name of a company. The third column here represents the position of an individual in a company. So what position the current person is holding right now. And the fourth column is the state variable. What it says is whether the current position is being held by that person or not, or whether that position has been ended for that person, right? And what we have to do is we have to create these table from this given paragraph automatically. The system has to do this task automatically, right? So let us try to see what the system has created here, or like what system has extracted here. What it is showing is there is a person, Russell T. Lewis, right? He was working in New York Times newspaper. Like his company is New York Times newspaper, and his position was like is president and general manager and state staff. Right? So that means currently he is holding this post in what company? New York Times newspaper. So where is this particular information present in my paragraph? It is present in this first sentence. New York Times company named Russell T. Lewis, 45, president and director manager of its flagship New York Times newspaper, responsible for all business side activities. Right. So this looks very, very difficult task. Actually. This is actually a very difficult task. Given this sentence, I want to extract this very, very structured information. Right. So this is called a structured information. This is called unstructured text. Okay, structure why structure? Because you want to know, like you should be able to know that this particular set of words represents a name, right? This particular set of words represent a company name. This particular set of words represents a position name, and particular like this. So what and what whether that particular person is actually holding that post or not, right? So all these are kind of some way to encode this information into your program, right? If your program is kind of good, if it's doing good, then it will be able to extract all this information from the unstructured text. Okay, so what it has extracted later, it is showing me that Russell T. Lewis, uh, uh, he was like he was holding a position of executive vice president. So that position is ended. That means he was holding right where in the company New York Times. So from which sentence this information was extracted? This one. He was executive vice president and deputy general manager. Okay, so executive vice president. So this information has been extracted here. Similarly, the last row says Lance R. Primus, New York Times Company, President is CEO, and this is the position he is currently holding. And this we can extract it from the third sentence. Lance R. Prime, he succeeds Lance R. Prime, who in September was named President and Chief Operating Officer of the parent. Right. So, hello. Okay. So that's how, like, so that's again kind of a very, very difficult. It's not that easy, right? So to create a program which can extract all these kind of information automatically from the unstructured text, right? And this problem is called information extraction in natural language processing. So you want to extract some very specific information from the naturally written text, right? And these names are called entities. So like Russell T. Lewis is some entity, Lance R. Prime is New York Times Company. All these are different entities, and then you find relationships between two entities, isn't it? So for example, the relationship between Russell T. Lewis and company is what? Person is working in this company, this person is working in this company, this person is working in this company, and so on and so forth, right? Position in company, so so like person and post, it is holding this post. This person is holding this post. This person is holding this post, right? And so on and so forth. So information extraction is subdivided. The problem is information extraction subdivided into two sub problems. One is entity extraction, where you have to extract these entities, and the second problem is like you have to associate these two entities. Like what is the relationship between two entities? Fine. If you can do this, you can easily construct these kinds of tables. Have you seen this thing before somewhere? Do you think that this is an interesting problem? It can help you somewhere?
So for this, we should have the unstructured data in any specific format or any format it will do.
Any format will work. If your program is doing good, like if the program is kind of very good, like it has been experimented very well, then it can work with any kind of unstructured data. For
Sir,
example, you can pass the abstracts of all, like the first paragraph of all the Wikipedia articles of different people. It should run.
so these attributes of structured table, are they they varied based on the kind of paragraph we are trying to analyze, or will it be static, fixed?
No, no. So this depends on what task, what kind of information extraction you want to do. Right. So in this case, suppose we have 5,000 articles, and all these articles are talking about some kind of people, right? So, like for example, people like it is talking about some employees of Google, some employees of Facebook, some employees of Amazon, and so forth, right? And suppose we just want to create these kind of tables. So that is a very specific case. Another case could be that suppose we have research paper, right? And as an input, what we are passing to our system, the aspects of all these research papers, right? And like all these research papers are related to some kind of gene, right? Genes, and like if these genes are regulating some kind of protein, right? So that information is present in all these aspects. So maybe your table will be slightly different. These the entities would be different. So maybe the entity would be the name of a gene, right? The entity could be the name of the protein. The entity could be the name of pathway that it is the gene is using to to generate these proteins, so and so forth, right? So it depends on what kind of task you want to solve, and accordingly
Yeah.
you will create your system.
Yeah, so the scientist who is doing this extraction will first try to define what kind of extraction he wants to do, and accordingly he will define the table, and then
Yes, yes,
the algorithm will extract. Okay, okay, sir. Thank you.
yes, 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 yes. Yes. So it is also the case. So just please note that it is also the case that based on your problem, your system might not do good also, right? So sometimes your code might do good on some specific use cases. It might not do good on rest of the cases, right? So for example, suppose you have created an information extraction system for this kind of task, like the one that I'm showing here in the slide. Same thing you want
Yes.
to do it for some other task, right? It might not do good because it was created for this kind of use case. It was not
Domain
created for that
specific.
kind of use. Yeah, yeah. So it is very
Yes.
very domain specific. I agree. This is very very domain
It's a
specific.
classification problem. Yes, sir. Thank you.
Yes, yes. You can consider it as a classification. Yes, people are trying to consider it as a classification problem. Yes. Some people try to consider this as a sentence labeling problem also, or like
Okay.
the token level labeling also, sequence labeling problem also, right? So there, those things are there. Yes. It is up to you how you define this problem. Yes. Okay, so I hope the idea of information extraction is kind of clear. Okay, this is fifth application of natural language processing, and the name of this problem is sentiment analysis. I assume that most of you have heard about this problem of the sentiment analysis. This is kind of again very popular natural language processing task. Okay, so the idea here is that you are given a review. Review is what? Some text. Right? Review is what? Some text, and this text talks about some product. The product could be some software, product could be some mobile phone, product could be some desktop, laptop, and so on and so forth, right? And like what do you write about that? Whether that desktop is doing good or not, whether that like desktop has some problems, some issues, and so on and so forth, right? So that other people who wants to buy that particular product should look into your review, and then based on that they take their decision, right? So one of the very interesting tasks is that given the review text, you want to find whether it is talking positive about the particular product, or that review is talking something negative about that product. That's a very simple task, right? Given a review, we want to have three different classes: positive, negative, and neutral. Right. So there are three different classes that you want to categorize that review into, and this problem is called sentiment analysis problem. Okay. So how does our system look like? It is kind of a black box. You are passing a review here, and then it gives you the prediction, right? It gives you whether this is positive, negative, or neutral, and based on that you take the decision. Now that seems to be very very simple problem. What is the challenge here? Anyone who can come up with a challenge?
Sarcasm detection.
sarcasm section is yes. So maybe like within a review, he was talking about the product, right? And then even though he is sarcastically saying that the product is very good, I liked it very much, but actually he meant by that sarcasm was that the product is kind of very bad. So I heard a very sarcastic sentence about. I remember it was, I think, about iPhone 12s. That person has to sold his kidney for buying this kind of the iPhone, right? So even though he was saying that iPhone is kind of very good, I liked it very much, I was waiting for it for so many days, I have to sell my kidneys to buy it. So it was kind of the hidden sarcasm which the person was talking about, right? And that is indeed very difficult problem. Yes. Any other problems that you think could be a problematic here? Have you seen some of the reviews which people give in Flipkart, or some of the reviews which people give in like Amazon?
Sir, are you talking about aspect level? Uh, that is context related something?
No, not text filter. Simple, simple. Just a plain review. Just a plain review. Right. Okay. Let me just tell you what the problem is. What could be one of the problem is that one of the problem which you will find is that like if suppose we are trying to write a review, right? If we suppose want to try to write a review, we will write a review. Along with that, we will write a lot of garbage also, right? And if you are trying to create as a researcher, you want to create a system which detects the sentiment of that review. It will not only look into the good words to talk about the sentiments in that review. It will also look into the garbage which the user has written. By garbage, I mean that maybe the user has added some smileys, right? It has added some emojis in the review, right? It has added some arbitrary symbols which are completely unrelated with the review, right? Sometimes people are mixing different languages. Even though everything is written in English, some of the words are in Hindi, right? So all these things makes all these like the review sentiment analysis stuff very difficult, right? And this is true also if you consider reviews mostly like English written reviews in Amazon and Flipkart. So we as a Indian, we are kind of not so much like proficient in English, right? We mix English with Hindi, we mix English with Marathi and so on and so forth, right? So our reviews are not correct grammatically, they are also semantically incorrect, right? And if you want to train your sentiment analysis system on these kind of reviews, you have to think very like carefully whether your system is going to work on this kind of systems or not. We will talk about such kind of problems in the later part of the slide. We'll see those set of problems, right? But another very interesting thing is that whatever, like, so it is not that these are the only problems. There are many other problems, right? And people have tried to solve many of these problems by constructing a very good set of tools also, right? But one of the very challenging problem is that most of these tools are actually developed for English language, right? So which assumes that people who have written these reviews know English language very very well. They know it grammatically. This is correct, right? And semantically also the reviews are kind of correct. That's the assumption of most of these sentiment analysis tools that you'll find today. Okay, so directly using those tools in Indian context is again a very challenging task. You cannot just use those tools because here the way we write these reviews is like very difficult. It's very different than the English audience writes their reviews. Fine. So that's all for like the sentiment analysis. We'll see some of these problems later in the later set of slides. Okay. Okay. So there are a few more very recent applications. One of the very recent application is fake news detection. Right. So fake news detection and what kind of platform do you think that which are peddling a lot of fake news these days? Do you have have you seen any fake news which has come to your social media handles, which has come to your messenger, WhatsApp like platform? And what do you think? Whether like is it easy task to identify whether a given article which has been forwarded to you, like, or which has been passed to you, is a fake news or not? Do you think it is an easy problem? Some promotional news, yes, right. So that's what. So as a human, we know that this is kind of not a very easy problem, because the reason is kind of very simple. That suppose an article has been forwarded to you, right, and it could be a potential fake news, right? How to verify that particular article, right? So what you have to do, you will look into all possible articles which have been published before this article has come, and then you will extract facts from those previous articles, and then you will try to match those facts with the facts which are present in the potential fake article, right? If these facts are matching, that means this is not a fake news article. If the facts are kind of not matching, or they are kind of contradictory, that means this article is again a potential candidate for the fake news. Okay, so having said that, whatever, so there are again lot of news agencies, there are a lot of private companies which are right now doing this fake news, which are kind of working as a fake news buster, right? So they will burst all these fake news. Again, if you see their, like, how they are trying to work, they are mostly trying to work in a very semi-supervised way, right? What I mean by semi-supervised is that they will have a program which will give ratings to different articles which have been written by these people. Right? Whether this article is a candidate for a fake news or not. Right. So among suppose they got 1,000 articles from internet, their code, their program will attach some ranks to these articles. That these may be these, out of these 1,000 articles, 10 are seeming to be containing some fake news, right? And then what these agencies will do, they will pass these 10 articles to 10 different people and ask them to see whether this is actually a fake news or not, right? So this is not completely supervised. So this kind of not completely automated. It's kind of done half with the code and half with some humans. Right. So again, if you see here, there is ample opportunities here. There is ample opportunities to create systems which can actually help us to detect the fake news. Now, this problem is even more difficult in case of Indian scenario, where if you see the articles, the kind of messages, the kind of things that have been forwarded to us are not just in English. Right. So, like, if you are, like, if you speak Marathi, then most of the things that will be forwarded to you will be in Marathi. Right. Many other things which are getting forwarded to me are Gujarati, even though I don't know Gujarati. Because I live in Gujarat, many of my friends used to pass me some messages which are in Gujarati, right? And if I don't know a language, or if I like, so there is a kind of diversity, right? So if you have created a tool in English which can detect fake news, it won't work in the same tool cannot work for Gujarati. Right? So that's how that's kind of the problem that we have in the Indian context, and that's why we are kind of facing a huge surge in the fake news these days, because there are no tools which can detect this huge amount of fake news which is being generated on large scale. All the agencies are kind of doing it manually, almost manually. Okay. Any doubts there, guys? So any comments that you have here? Yeah. Okay. Great. So let me move to the next application. So yeah. So this is again a very interesting application of natural language processing, and this is called chatbot. So I know we have seen some chatbots before. So I will describe what I mean by chatbot. But have you heard about some chatbot, and have you seen some chatbots before? You have seen some chatbots. Okay, that's very good. That's very good. Yes. So what I mean by chatbot is that there is a machine. So there is this machine which is behind your mobile or your desktop, or that is behind the internet, right? And you are interacting with this machine, and this machine is behaving as if you are interacting with a human, right? So this person is interacting with this machine, and to this person it seems as if he is talking with some humans. It's not machine on the other hand, right? And that's why these are called chatbots. You're chatting with some bot, and this bot is answering as if he is a kind of a human. Okay, so constructing these kind of chatbots is again a very challenging task these days. But we see a very like good quality bots also, which are kind of like with some success rate, they are kind of able to answer our queries, right? And one of the very like limitations of all these bots is that they are very domain specific, right? By domain specific, I mean that if suppose you are logging into IRCTC, right? So it can only answer queries which are related to trains. Right. If you're logging into some bank website, right, it can only answer very specific questions related to bank account, right? Suppose it cannot answer anything related to trains. So these are kind of very specific domain specific chatbots which people are trying to construct these days. Okay. So that's one thing. Another thing is why do we want to create a general chatbot? So if we can create a general chatbot, that would be kind of very interesting. And there are some general chatbots also. For example, Alexa. Right. So Alexa is kind of a very general chatbot. You can ask anything. Right. But what's the problem with the Alexa? Has anyone seen any problem with the Alexa or the like Siri in Apple products? Have you seen any kind of challenges in these systems, in these chatbots? Even with the Google search, voice search. Yes. Lack in understanding of Indian. That's true. Yes, that's the biggest challenge. I understand. That's the biggest challenge. Yes, that's true also. So one of the biggest challenges. So why are we talking a lot on like natural language processing these days? The biggest challenge is that we as Indians are generating a huge amount of text. We are generating a huge amount of data, be it in the form of text or be it in the form of the spoken data, right? But the tools which are available to us do not understand this. Even very popular systems like Alexa, right? You or like Alexa or like Google Voice Search. You are searching for something in YouTube, it will show you entirely different results because it's very difficult for these systems to understand the way we speak English, the way we speak English or the way we speak Hindi, right? So if you're speaking English, it might be able to give you some results. But if you are completely speaking in some of your native languages, it is kind of like very difficult for them to like come up with the search results for you. Okay, so I hope you are kind of okay with like the challenges at least in the chat box and the opportunities also. Huge opportunity is there in constructing these chat box of native languages, and there are many such like many such opportunities which you will find in chat box. Okay, so we have seen some applications. There are many more other applications like text summarization. You are given a huge amount of text, maybe 1000 documents. You want to create a summary of 50 words. That's called text summarization. Again, that's an NLP task. Opinion dynamics. So opinion dynamics is very similar to sentiment analysis. Here, maybe we want to see that given a product, right? So suppose Kia is about to launch some new car, right? And before launching, it wants to see what people are talking about it. What is people's opinion? So it might do something that maybe it will launch. It will try to it will launch a video. It will launch a trailer, and then it will try to look into how people are talking about this trailer in YouTube, how people are talking about this trailer in Twitter, right? So they want to gauge the opinion of the people over a time of like 15 days before the launch or till launch or before like three months before the launch. And based on these opinions, they might make some specific changes in the product. They might change the pricing also of these products and so on and so forth. Okay. Similarly, other goals of NLP could be that maybe you want to detect spam. So spam detection is again a very popular NLP task, and this is something that we do on a daily basis, right? So all our Gmail emails are first filtered through a spam detector. If an email passes that detector, then only it is shown in our inbox, right? Otherwise, it is being pushed into our spam folder. Okay, there are many such applications of NLP, many such applications of NLP. Right. So natural language technology is not yet perfect. We have seen the examples, but it is still good enough for several useful applications that we have seen. Right. You can use it to some extent, but it is still not perfect. There is still long way we have to travel so that we can make it perfect. Oh, so that's all for the first session of this, like my talk. We'll meet again after 15 minutes, and then I will be mostly talking about why NLP is hard, and if time permits, we'll talk about the different, like how you can construct a course for natural language processing, right, and how you can evaluate students and few more things. Like we'll see what things we can cover there. Yeah, thank you for that. Yeah. So, so the current time is 11:30. We'll meet at around 11:45. Okay. Yeah. Thank you.
10-15 minutes break.
Hello, am I audible?
Yes, sir.
Okay, okay.
Yes,
So
sir.
let's start.
Yes, sir. You can start, sir.
Yeah,
Yeah, you can start, sir.
yeah, yeah. Sure. Hmm. So till now we have looked into some of the applications in natural language processing. There are many such applications which we'll see. Some of them, some more we'll see in the next set of slides. But these are some of the most important. Like I discussed around 8, 9 different applications which are kind of one of the most important applications in natural language processing. Okay. So now let us look into why natural language processing is a very hard task. Okay. We have seen some examples why it is kind of hard, but let us now look into some of the main like more popular things which are kind of very hard to solve. Okay. So one of the like very challenging tasks is to understand and break these compound words. So if you read here, it is a single word in Sanskrit, right? And this word has 195 characters in Devanagari. And if you convert this entire word into Romanized English, then there are 420 characters. But it's still this entire thing is a single word in Sanskrit. So what's the problem here? Now suppose I want to process this particular word in like in Sanskrit, right? So what I have to do is I have to look into the respective meanings of the different words which are present, the subwords which are present inside this huge word, right? And for that we need to identify what are the subword boundaries, right? So for example, in this case, like this nirantara, like nirantara and dhakaris, this is a single word. That digantara, this is another word. And lad makand, right? So this is another word. Then sudharas is another word. Bindu is another word, right? So if you see this word, the way this word will be inputted into your compounding or like the word like into your system, which creates these small subwords from this large word, a system should understand that this is the first subword boundary. This is the second subword boundary. This is the third subword boundary. This is the fourth subword boundary, and so and so forth. Right. So this is one of the very challenging tasks in NLP, where we want to uh, create subword from a very large word. Right. It could be Sanskrit, it could be any other word. So similar things we can see in German also. Similar things we can see in Chinese also. Right. That's a very global issue, and that is present in almost all languages. But have you seen this word before? Have you seen this kind of word before? No, it's okay if you have not seen this before, right? But this word has 195 characters. So it's one of the, it's actually the longest word in any language globally, right? So this is the longest word in any language globally, and that word is present in the Sanskrit. The length of this word is 195 characters in Devanagari and 428 characters in Romanized English. Okay. Okay. Along with the compounding, where you want to break the compounded word. So compounding is we are combining several words together, right? So another challenge is that ambiguity. So there is a huge amount of ambiguity that is present, right? And if the sentences are ambiguity, it is not possible to understand these sentences well, right? So let us try to see what I mean by ambiguity. So one of the possible like reason of ambiguity could be the lexical ambiguity. What I mean by lexical ambiguity, just read the sentence. I saw her, right? So this is the sentence. It can have two interpretations. The first interpretation could be that there is this girl, and since the football was coming over her head, so she has to duck. Right? She has to just move up down a bit. Right. Similarly, the second interpretation could be that this lady has a duck, right? And then she is kind of walking with her duck. right? So both of these interpretations are correct, isn't it? I saw her duck. I like saw her duck. So that means like with a duck. So just before I go ahead with the explanation, just let me interpretations are correct for a given sentence, isn't it? But see, there is a very slight difference. So, for example, here, if you see this word duck, this duck is noun or it is used as a verb here for the first interpretation. For the first interpretation, I saw her duck. Is this a noun or a verb? So Apeksha is saying that this is noun. Anyone else? Anyone else who thinks that this is a verb? Or everyone thinks that this is a noun? Okay. What about the second interpretation? The duck is considered as noun or verb? The second it is considered as verb. Okay. Actually it is reverse. Right. So here the first interpretation of I saw her duck. So this is duck is used as a verb, right? And here it is used as a noun. Because duck in this sentence is some object, some real world object, right? Here it is a motion that the lady has to come down. The lady has to come down, right? So that means here this is the word duck is used as a verb. Here it is used as a noun, isn't it? So a given word can have multiple POS tags. POS tag, whether this is adjective, whether this is noun, adverb, adjective, pronoun, right? All these are different POS tags. So a given word can have multiple POS tags. It can occur in different PO stacks, and based on like it's present in different PO stacks, it can be assigned different meanings. So if we are not sure what particular intuition of that needs to be used, then we cannot create a system. Right? We cannot create a system if the system itself is confused what interpretation of that needs to be consistent. Right? Any kind of system. Right? So suppose I want to create a machine translation system. That translation for this would be very different than the translation for this, isn't it? Is it correct or not? Please confirm that the translation for this kind of intuition would be very different than the translation for this kind of intuition. Alright, so the machine translation system should also be very sure of what kind of pure tag this particular word duck is present, right? So again, sometimes it is kind of not possible for a system to make you understand, and that's where this ambiguity issues have come. So in case of lexical ambiguity, what it means is the presence of two or more possible meanings within a single word. If a word can have multiple meanings, then it is sometimes called the lexical ambiguity. Okay, so that's lexical ambiguity. There is another kind of ambiguity, and this is called syntactic ambiguity. The presence of two or more possible meanings within a single sentence or a sequence of words. For example, the sentence is, the chicken is ready to eat. The chicken is ready to eat. It has two interpretations. The meat is cooked, the chicken is cooked, and people can eat it, right? That's the left interpretation. And the right interpretation is that the chicken was sitting on a table, right? It was sitting on a dining table, and the chicken is waiting for food to come. Both of them are correct, right? Based on this sentence. So this is called syntactic like ambiguity, where like the word itself doesn't have ambiguity, sentence has ambiguity, because some words like some combination of words are creating this kind of ambiguity, right? If you have this kind of ambiguity, it's difficult for any kind of natural language processing system to process this text correctly for any kind of application, be it be it machine translation or any kind. Okay, a very interesting example here, which talks about ambiguity. Please read this sentence one. Please read this cartoon one, and then I will describe what's the ambiguity here. Yes. So here, this person, he was watching a news, and in the news it said that four armed gunmen robbed a bank. Four armed gunmen robbed a bank, right? Like this person can, based on this sentence which the speaker was kind of speaking, he can think about different scenarios in his mind, right? So, for example, he can think about like four armed gunmen robbed the bank. There were four people. They have some arms and they have robbed the bank. That's one scenario. Another scenario could be that there were like people who have four arms. Each person has four arms, and these people have robbed the bank, right? Another possibility is four armed gunmen, right? So these are not like humans. So these people have guns on their head, right? And each person has four arms, and this kind of creature has robbed the bank, right? So what among all these three possibilities you think is correct? Which among these possibilities you think is the correct? This is the first possibility, this is the second, this is the third. The first possibility is correct, right? And why do you think the first possibility is correct? Like why you are so sure that the first possibility is correct? The reason is these kind of creatures do not occur in the real world. The creatures in the second and third, right? But for a computer system, it is very difficult for them to make these things understand, right? For a computer system, if you give them this word, they can come up with all these interpretations. Computer system doesn't have knowledge, right? So you have to embed, you have to somehow code this knowledge into the computer system that human beings do not have four arms. Human beings have a head, like on top of their body. They don't have guns on top of their body, and based on that, it has to take the decision. Fine. You understood what I mean by ambiguity here? I showed you different kind of interesting examples to understand what I mean by ambiguity in the sentence. Okay, should I move to the next slide? Okay, fine. Okay, so that's not just these two different challenges, right? There are many more challenges. So another challenge is called, says we are noticing a lot of shorthand text. Lot of shorthand text. That means the word in English has been created a short form, right? So, for example, read the conversation. Just read the sentence between these two young people. What is this lady saying? C U I will T X T U L 8 R. C U I double L T X T U L 8 R. Then there is some smile here, right? So what's the what? So this is. Do you think that this is a shorthand text? How many of you think that this is a shorthand text? Okay. So okay, at least you can agree that this is a shorthand text. And what if we expand all these different words? What will be the sentence if I expand all these words? You can type it in your chat box. See you, I will text you later. Exactly. Right. Now, suppose that, yeah, that's true. Yeah. So even see you is not correct, right? So I think, Renuka, so your answer should be FEE space YOU. Right. And then instead of U, it should be YOU. Then only it is correct. Right. Yeah. Okay. So, one thing which you need to see here is that if suppose you had created some kind of natural language processing system, right, which only has the English vocabulary, the standard English vocabulary with you, right, will it be able to process this kind of text? It won't be able to process this kind of text, right? It doesn't understand what I mean by C, doesn't understand what I mean by just U, right? I doesn't have any word TXT, it doesn't have a word U, right? It doesn't have a word L8R. Right. So this entire sentence will look like a sentence in some foreign language for a system which has been trained on an English vocabulary, isn't it? So what I'm saying is that making sense? Like any kind of system that you want to create, any kind of application you want to create. So your system should be able to understand these kind of shorthand text. If it cannot, then it's kind of difficult to make it understand. Am I not audible? Hello? Yes. Oh, okay. There is some problem with, I think there is some problem with Dr. Manjari's speaker there. Yes. Okay. Okay. That's fine. Okay. Now this problem is clear, right? The problem with the shorthand text. Okay. There is also a problem with the non-standard English. Just read a tweet by Shah Rukh Khan. So Shah Rukh Khan is saying, reprimanded by team, so again at the rate Varun Sharma 90 THKU. Sorry, had to leave. At the rate Varun Dhawan forgot to tell you ABCD2 looks really cool and energetic ATB. Would you think that a system which has been trained on standard English vocabulary work on this will be able to do a good performance on this or this text? No. What are the words which it cannot process? What words in this sentence you see it won't be able to process? You can type it in your chat box. At the rate, yes, all these mentions are not present in my English vocabulary. So system won't understand what it means by these at the rate. Yes, that's true. Yes, it won't be able to process. THK, it won't be able to process. Hash, yes, hashtag, it won't be able to process. That's true. ATB. ATB is not present in my English dictionary, in my English vocabulary, right? So it is not going to process ATB. What I mean by ATB, I don't know, right? Similarly, here you see the reply by Varun Dhawan. So he says, "Thank you, sir. Means a lot. Means the word that you find ABCD2 cool. I'm sure Ramo sir will be very happy to know this. At the rate I am fine." Right? So here also there are many things. For example, the word you. This hashtag ABCD2. Fine. So these are the different things. These are the different words which are non-standard English words. And if you have these kind of words in your data, then you have to take care of these words. Otherwise, your system will get confused, and whatever task it was assigned to do, it won't be able to do that task efficiently. Okay. So suppose you are given this kind of table, like this is just a very simple example. This very simple question for you. Suppose you are given this kind of text, this text, right? And you have to extract all the movie names from this kind of text. So what movie name do you think is present here in both of these tweets? ABCD2. Yes, ABCD2 is the name of the movie. And as a human, how do you know that ABCD2 is a movie? Because you have seen the promotions. Okay, someone is saying that yes, it is related to the word Remo. Okay, people might have seen the movie also. Some of you might have seen the movie also. That's why you know that ABCD is the name of a movie. You have seen the trailer also, right? Now think in terms of a system. Think in terms of a computer program. Will it be easy for a computer program to come up with an output that yes, indeed ABCD2 is a movie? Will it be easy for a system to identify that ABCD2 is a movie name from this entire text or from this entire text? No, right? So that's why I always say that it's not that easy, right? It's actually very challenging because the way we are kind of writing English these days has completely changed the way we used to write English 10 years before or 15 years before. And this is happening thanks to thanks to these platforms like Twitter, Facebook, Instagram, right? So this has entirely changed the way we are kind of writing English, right? And the systems that we want to build, most of the systems that we are currently trying to build is is based on the traditional English that we used to write, or the traditional Hindi that we used to write, right? And these systems are not going to perform on this kind of text, because these texts are not following any grammatical rules. These texts are not following any kind of semantics. These are just like very, very informal text, right? So that means it's kind of difficult to do any kind of NLP task here. But that's why NLP is kind of very, very problematic. It's very hard to do also. Okay. There are few more very standard limitations of NLP. For example, it's difficult to segment. For example, you have this sentence: the New York New Haven Railroad. What do you think? Like, what are the positions here where you think the segmentation will need to happen? Right. So, for example, I segmented. I kept the as it is. I kept new as it is. I kept York new together, heaven as it is, and railroad. This is one possible segmentation of this entire word, the entire sentence. This is the sentence, input sentence. This is one segmented example. This is another segmentation example. What do you think is the correct here? What do you think is the correct segmentation? Segmentation means dividing words or like combining words together. The last one. Someone is saying the last one. Apeksha is saying the last one. Anyone think that the first one is correct? The last one, right? So most of you are saying that the last option is correct. Yes, indeed the last one is correct. Why do you think the last one is correct? Okay, so Vaishali is saying the New York New Haven Railroad. So that I think that is not correct, because railroad is associated with both of these together. Yeah, so that's why railroad is not correct. So the correct one is this one, the second one. Okay, but why do you think as a human this is correct? Why do you think that New York will come together, New Haven will come together? Because it says a New Haven is a railroad in New York. Yes, so that could be true. No. My question is that why New York has come together, New Haven has come together. Because so as a human, you know that because you have heard the name of New York, right? So you know that New York is the name of some city. New Haven is not as popular as New York, but again, you can infer that maybe New Haven is again some name of a city, right? So as a human, it's easy for you to again make sense of like how what needs to be combined together and what can be just kept as it is. Okay. Problem is with the computer. Problem is with the computer. Same task given to a system, and it is asked to combine words together. Right. So it can do any of these segmentations. Right. We have to make the system intelligent enough so that it can come up with the correct segmentation. Isn't it? So again, this is a very challenging task. So one very simple way to make computer intelligent is that whenever the word New York is coming, or whenever the word new is coming, it can see that what other words are coming after new, right? And if there is a specific word, suppose York, which is coming after new, it should see in the some corpus, some data set, suppose the entire Wikipedia, that is New York coming again and again or not. If New York is coming again and again, that means it is possible that New York should also come here together. Similarly for New Haven. So this is some kind of very basic intelligence that we can embed into our program, and based on that, that can come up with some segmentation rules. Okay, fine. That looks okay, and that seems that segmentation is the issue. Yes. Okay. Another problem could be that it is kind of difficult to understand the idiom. Fine. Okay. So, for example, suppose you have idiom as dark horse, right? And you have an idiom as ball in your coat, burn the midnight oil. So these idioms will only make sense. These idioms will only make sense if two words are combined together. are like taken together, then only this idiom makes sense. Ball in your court. So if I suppose I want to create a machine translation system, right? And this word dark horse was present in one of the sentences. Now, if your system is translating word by word, it will create a very different meaning of dark horse, right? Maybe uh, some dark will be converted to some Hindi word, corresponding Hindi word, and horse will be corresponding to the ghoda. Right? So kala ghoda, yeah, something like that. Similarly, ball in your court. Ball in your court. If you're trying to create a like translation from here, each word will be converted to its corresponding meaning, right? If your system is not very good. Similarly, burn the midnight oil. If your system is good enough, it understands, yes, that indeed these words are coming together. They have a very specific meaning if they come together. And these words might represent some kind of idiom. Then do not convert this word, like this phrase word by word. There is a specific meaning of this phrase, convert to that, right? So identifying idioms is again a very challenging task. If a system can identify idiom, then I think the translation will be much better than it is currently these days. Now, you can always argue that why not create a vocabulary of all possible idioms in Hindi or all possible idioms in English, right? And then whenever a system is trying to do this machine translation, it just looks into the list of the idioms and performs the translation. That actually is a good suggestion, but that will not work in the real scenarios. The reason is every day we are coming up with new and new idioms. So this list is not fixed. Every day we have to come up, we have to update this list. Right, and that's why this kind of thing, this kind of like solution is not feasible. Okay, any doubts here? Fine. Okay, so along with the idioms which a system should automatically understand, there are few more words. Words like unfriend, retweet, Google, Photoshop, and these words are called neologisms. These words are called neologisms. So by neologism, I mean that these words were not present before, but these two words have come into our vocabulary, right? So a system which has been trained on the traditional English vocabulary won't be able to get and like won't be able to understand these words. Right? But these days we are using a lot. Like we are unfriending people. So unfriending is a verb these days, right? Do you want to unfriend me? Why have you unfriended me? Like you can unfriend this person. All these are verbs. These are verbs, right? Please retweet my tweet. Have you retweeted it or not? Right. So again, retweet is verb. It is a verb. Just go for just do it. Just do Google it. Right. Do just do this Skype. Please Photoshop this image. Again, all these are used as what? Verb. So these are the new words. These are the new words which have come into our dictionary. And most of these words are called urban. These words are called like urban verbs. So these words have come into our urban dictionary. Unfriending, retweeting, Googling, Skyping, Photoshopping, and so on and so forth. Some of the other words could be like WhatsApping. So just WhatsApp me. What is WhatsApp? WhatsApp was not present in the English dictionary before, in the English vocabulary before, right? So WhatsApp is again a new word which has come into our the way we speak these days English, right? So system should understand these new words also. Okay, now this is about new words. These are new words which have come. There are some words which are present before, right? But their meanings have changed now, or their other meanings have become more popular than their previous meanings. So, for example, read the first sentence. That is a sick dude. That is a sick dude. What's the meaning of sick here? What's the meaning of sick here, based on your intuition? Bad. Okay. Any other guesses? Stupid, disgusting. Anyone else? Okay, so based on your intuition, you are saying that this word has some negative sense associated with that, right? But actually, that this is not the case. The new meaning of Sikh is is person who has some. Okay, so just let me see its meaning here. Just a second. The meaning of Sikh. Yes. So the actual meaning of Sikh is you are present, right? So the meaning of Sikh is a person who is amazing, right? So it's a positive. It has a positive sense. It's not a negative sense, right? But one thing, the thing that I want to stress here is that the word Sikh used to have a very different meaning before, right? Before, suppose like 2010, it used to represent illness. If someone is sick, that means he is ill. These days, we are using a very different meaning of sick, and that represents a personality of a person. That's a sick dude. That means that's an amazing person, right? So, if your system is just considering a single meaning of a given word, that also is not going to work because with time we are kind of changing different meanings of this word. Okay. Another example could be giant. So what do you mean? What do you think would be the meaning of giant before? And what's the new meaning of giant? Yes. So giant could be very huge. Words like large, huge, big, all these words were the traditional synonyms for giant, right? These days, giant is used in association with companies like multinationals, a company which is being operated in multiple countries, like conglomerates, so mining, like multi companies, a group of companies, right? So that means it's a tech giant. Manufacturers, huge manufacturers, like so steel manufacturers. People are, yes, for example, Aman, yes. So he is kind of a giant. So the meaning of giant has also changed over the time. So earlier it used to be synonymous with like words like big, large, right, enormous. These days it has been associated with organizations, huge organizations, big organizations, right? Like multinationals, conglomerates and manufacturers. Okay. So the system should understand these new senses of the word. Okay. Now, the system should also understand that combination of words is not just some random phrase. It might represent some entity name. For example, consider the first sentence here. Where is a bug life playing? Where is a bug life playing? So here the phrase a bug's life is a name of some entity, right? It might be a name of some place, right? A bug life. So it's name of a place. So if you want to convert this entire sentence into Hindi, you need to consider a bug's life together, right? That you will convert a into like bugs into some word in Hindi, life into some word in Hindi, right? This word should come together as it is in Hindi. Rest of the things can be converted. Same thing could be let it be was recorded. Right. So here, let it be some song. Let it be some song, right? So the system should understand that let it be is the name of some entity and it should be kept as it is. So entity names do not need to be converted into the respective language. Right? They can be kept as it is. Rest of the things can be translated. Okay. So I hope you understood the problems in NLP. Do you think some other problems might also happen? Do you have some other suggestions, or you think like maybe you can come up with some more problems? Any other problem that you can think about? Okay, no problem. Yeah, no issue. Yeah, emoticons. Yes, emoticons is again a problem. Yes, so these days, like we are using a lot of emoticons while we are performing some conversations, we are also using a lot of GIFs, isn't it? So in WhatsApp, we are using a lot of GIF to represent our to represent our emotions, to represent our carry on our conversations, right? So understanding these emoticons, understanding this GIF again, right? So it's not, so these days it's kind of become a multi-modal kind of conversations, right? We are conversating with each other, not just in a textual manner. Forwarding some images, we are forwarding some videos, we are forwarding some emoticons, we are forwarding some GIFs, right? All of this is part of conversation, and we have to understand all of this to understand the conversation. And that again is very challenging. Now from the perspective of the like from the Indian perspective, this is a huge problem. Can you understand the problem here? So this problem is called code mixing and code switching, where like you are writing a sentence in Hindi, but you are picking some words from other languages. For example, the first sentence says, the first ad says, मेरे परिवार की स्माइल बनी रहती है दिन भर. What is the foreign word here? What's the foreign word here? Smile, right? So you have used a foreign word and you converted that into an Hindi, into Devanagari, right? So मेरे परिवार की स्माइल बनी रहती है दिन भर, right? So if suppose we want to run a sentiment analysis tool on this ad title, right? That will create a problem because smile is not present in my Hindi vocabulary, right? We need to think about something. We need to think about like considering like converting this word, or we need to do something, right? That's again the challenge we have. Another thing could be, so this was like we have converted English word into Hindi, right? Into Devanagari. The other thing is called romanization, right? So in case of romanization, what we are trying to do is we are converting Hindi to English, right? So for example, बहुत tension है. The grammar, if you speak of this language, is following what? Hindi grammar. The grammar is following the Hindi. बहुत tension है, right? But it is being written into Roman. That's the one thing. Second thing is some of the English words have also been taken. Percent, isn't it? Do you think that it might be difficult for a system to process this kind of text? Okay. What about this? The last one. The last phrase is even more complex. The reason is you are combining two words together. One word is from Hindi, this the word chutney, and ing. We are combining these together, and you are creating a compound word, chutneyfying, right? And chutneyfying word, it is neither present in Hindi, neither present in English. Right. Now what we want, our system should understand this kind of word. As a human, it's easy to understand, right? But as a system, as a program, it's very, very difficult to understand these kind of complex compounds, right? So people can always like you should have like you must have thought of like you should have thought of that maybe compounding is an easy problem. We'll just look into the word boundaries. If you find some words, we'll just break the compound there itself, right? That's not neither the check is present in English, neither ing is present in Hindi. So what dictionary you are going to look into, right? And based on what like rules are you going to segment this particular sentence of this particular word? Right? Do you think any other can you come up with some another set of examples? where you are doing some kind of code switching and mixing. So code switching and mixing is a general term, right? Code means language mixing and language switching. We are switching from one language to other. We are like mixing one language with the other. That's what it means. So can you come up with some such more examples? Maybe you can type in here in the chat box. Overifying. Yes. That's true. Yes. That's true. Yes. That's true. Yes. Yeah. Okay. So these are some of the problems which are kind of like which makes NLP very hard, right? And I hope you appreciate that these are indeed very hard problems, and creating a system out of this, like which can solve these problems, is very difficult task. Okay, so now let us try to summarize what we do in NLP, what we do in natural language processing. Okay, so in natural language processing, we do three main tasks. One is to create data sets, right? So one task is to create the data set like brown corpus. So brown corpus is one of them example. Like, so there are different kind of data sets that we create in NLP. And why do we create these data sets? So data sets can help us in solving a problem easier. Right. So for example, you have a data set called the Amazon review data set. For each review, an expert has associated and sentiment has associated a sentiment for that review. Like whether given a review R1, what is its sentiment? Whether the sentiment is positive, negative, or neutral. Right. Given a review R2, what is its sentiment? Given a review R3, what is its sentiment? And so on and so forth. Right. So that's what is called annotated corpora. So a manual annotation is required for many different tasks. So I was talking about a sentiment, annotated sentiment corpus, where for each review you have it associated uh, label that was created by some person, not a system, right? And then we will use these corpuses to like you will use these corpus to train a system, to train a program automatically. Well, that is something that I won't be discussing, but that is how things are being done. Right. So one task in natural language processing, and that's the main important task, is to create these annotated manual corpus. Right. So create this manual corpus. So there has been a lot of corpus which have been created before, like Brown corpus, Google Books, Ngram corpus, Reuters Newswire classification, IMDb movie review sentiment classification. Similarly, you have Amazon review sentiment classification data set also. There are Project Gutenberg and so on. So there are a huge number of data sets which are available for different kind of tasks. Right, that's one thing that people doing analysis. Second thing that people do is they create models or algorithms or slash programs. Right, so they will create these programs like LDA is one of them, BERT, CKY, added distance, CRF cluster. These are different kind of algorithms which have been developed for different kind of tasks. Right? And the third is we need to create some tools. So why do we need to create these tools? So that people who are not expert in natural language processing, but they can still do the natural language processing without even knowing the details of the natural language processing. Right. So for that, there is a tool called Core NLP by Stanford. There is a library called NLTK. I hope you have seen library NLTK. If you have not seen, just look for NLTK. It's very interesting, like a tool or library. It's in Python. Similarly, you have a library called Jensen. You have a library called SPI, and so on and so forth. Right. So these tools are used to like to perform natural language processing, even if suppose you do not have the like complete knowledge of different natural language processing techniques and like the the like theory of the natural language processing. That then also you can do some basic language processing. Okay, so these are the things that we do. We create data, we create algorithms, we create tools. Okay. So whatever I have talked about, like most of these things I have talked about in terms of challenges, in terms of like what are the recent, what are the applications. Now we will see the last one decade. what people are trying to do in the last 1 decade. So in the last 1 decade, people have moved from the traditional. So last 1 decade, there has been huge development in natural language processing. Right. So if I say that what kind of development has been done in last 1 decade, so this is mostly on like from the traditional natural language processing, people have moved to the deep learning side of the natural language processing. So I hope you are aware about the term deep learning. All right. So is there anyone who do not know deep learning? Is there anyone who does like who doesn't know about deep learning? Okay, so I assume that everyone knows about deep learning. That's good. So in the last like 1 decade, people are mostly talking about or they have converted this entire idea of natural language processing into the deep learning domain, right? So they talk about pre-trained models, contextualized models, from attention to Muppet models, ethics in NLP, zero-shot learning, federated learning. So I will describe some of them, and these are kind of the most popular recent developments in natural language processing. So I will describe some of them. Okay, so let us try to understand what I mean by pre-trained language model. So there could be a very simple model or means algorithm that suppose there is a kind of black box, right? There is a black box. The input to that black box is a review, and the black box returns the sentiment, isn't it? That would be a very simple natural language processing system. There is a black box. Black box means some Python program or some program that is being written. The input to that is a review, and the black box returns its label, whether that review is a positive, negative, or neutral. Fine. Now, it has been seen that this black box, which people have tried to construct. Suppose people have tried to construct this black box for IMDb reviews, or people have tried to construct this black box for suppose Flipkart reviews, right? Or they have constructed this black box for suppose Amazon reviews. What people have seen is, or they have observed is, that this black box is very domain specific. Right. So if you have created this black box for Amazon, then the same black box will not be able to correctly label the reviews which are coming from IMDb, or it might not work for the reviews which are coming from Flipkart. Right. So what people have thought about is that maybe we are investing a lot of resource in constructing these black boxes, right? But these black boxes are very domain specific. So that like whatever resources we are kind of investing in these constructing these black box, we are not able to reuse them for other purposes, like for other different domains. So people have come up with an idea called pre-training model. Right. What this idea is that you first of all you like break this step into two parts. So first step is called pre-training step, right? And the second step is called fine-tuning step. In the pre-training step, what you do is you do not pass any review data. What you let your system do is it tries to understand the basic construct of the language. So by basic construct means the grammar and the semantic of the language, right? So what I mean is that suppose you are passing the entire Wikipedia into your system, right? And there are no such labels, right? Just Wikipedia articles into your system. And what your system does automatically is it tries to understand what is the grammar of the English, right? It tries to understand the rules of the grammar, and it also tries to understand what each word represents. So suppose there is a word mango, so it should understand that mango represents a fruit. There is a word red, so red represents some color, and so on. So automatically, it does automatically, right? And in the second step, once you have created this very powerful, knowledgeable system, you pass this, you use this knowledgeable system to fine tune, right? You fine tune this very knowledgeable system, and fine tune according to your needs. So fine tune according to your domain, right? So if your domain is Amazon, you fine tune it using your Amazon review. If your domain is Flipkart, you fine tune it according to your Flipkart review, and so on and so forth. So what's the usage of this? So here the backbone model remains same for any kind of domain. Is the idea clear? The backbone model, the backbone algorithm remains same. Whether this is Flipkart, Amazon, IMDb, or so and so forth, right? Only the model in the second part changes, where we are trying to fine tune based on a given domain. So, lot of resources which have been invested are being shared among all these domains because we are using the same backbone model, right? So, this backbone model is called pre-trained model, and the domain specific model is called the fine-tuned model, right? And it has been shown that the two-step process leads you to better results than the one-step process. One-step process is anyway very conservative. It will not allow you to move from one domain to other. But the second is, even though it takes more time, but it is more useful and it gives you better results. Is this idea clear? The idea behind the pre-trained models and the fine-tuned models. Okay, so just whenever I say like model, you consider these are some program, right? So earlier there was a single stage program. This time we have two stage program. The first stage is pre-training. The second stage is fine-tuning. Fine-tuning is domain specific. Pre-training is domain invariant. Like, okay. So this is something which people have researched a lot, like huge amount of research, a huge amount of money has been invested on this pre-training language model. And the second advancement is called contextualized embedding, which I will talk about here, like very basic idea. So there has been a lot of work where like people are trying to understand or people are trying to represent the meaning of a word using some vector. So for example, if you have a word car, right, and you have a word truck, and you have a word apple, right? So what do you think? Car will be closer to apple or car will be closer to truck? As human. So you can answer this as a human, not as a machine. So car will be closer to truck or car will be more closer to apple. So like this is based on our intuition, right? So car will be more closer to truck, right? Why? Because both of them are used as the same means of transport, right? So both of them are used as a means of transport, and based on our intuition as a human, we can say that car is closer to the truck, right? Now, how are we going to make this thing understand to our system? How can a system decide that indeed car is closer to the truck, right? So there has been a huge research in natural language processing where we are converting a word to a vector, like where we are converting a word to a vector, right? And we create this vector such that the closer word will have a very similar vector. The distant words which are very far apart will have a very different vector. Fine. So, like suppose you have a car, and car has a corresponding vector. Vector is what? Vector is some list of some real number, right? Let's list of some real number. So car has a corresponding vector. The vector will be very similar to the vector of the car, and the vector for car would be very different, or if we compare it with the vector for the apple. Is it fine? Is the idea clear to some extent? Okay, so this has been done a lot. So there has been huge amount of research that people have invested on to construct these representations for each word. These are called vector representations for each word, right? So if two words are similar, they will have the same vector representation. Two words are different, they will have a very different vector representation. Right? Now, a word can have multiple representations. Is it true or not? Suppose a word bank, right? Bank can have different meanings. One meaning can correspond to the river bank. One meaning can represent, one meaning can represent the financial organization. right? So earlier search was what they were trying to do for a given word. They were trying to create a single vector. They were trying to create a single vector, right? And their assumption was all these meanings captured in a single vector. But it has been shown that the single vector cannot capture all these meanings, right? So for different meanings, you have a different vector, and that was these contextualized embedding. So in case of contextualized embedding, the embedding means the vector, right? So the new vector will be a vector for a given word will dependent on its context, right? So if the context is about, so suppose I am talking about the word bank, if the context is about a financial organization, then the vector will be different. If the context is about the river bank, then the vector will be different, right? So this is something which has been very recently done. So all these models like BERT, Elmo, and all the recent development which has been last 2-3 years, they are trying to construct these kind of contextual embedding. Embedding means vector, just a different name. Fine. So I have understood the difference. Like earlier research was to create just a single vector for a given word, right? Now people are trying to create multiple vectors for a given word based on the context that word is presented. So that gives representation of each of these words. Okay, so this is something that I won't cover. All these contextual, like there has been a huge research on attention idea. So idea behind attention is that like whenever you are kind of trying to do machine translation, right? So you have an input sentence, you have an output sentence. So the word in the output sentence will be dependent on some words in the input sentence. Right? So for example, two bui un Coca-Cola. What was its English sentence? What was its English translation? You drink a Coca-Cola, right? So the word drink in English is dependent on some words in French. For example, boy. So attention models, what they do is they try to identify this relationships between input and output. Right. So what it means is that to predict that the correct translation for the correct translation is drink, I don't have to look into the entire two bui un Coca-Cola. I don't have to look into the entire word. I don't have to look into all words in my input. I have to look into a specific word in my input, and that word is called boy. Right. So attention means you attend on specific words. Don't attend on everything in the input. Right. So these are very recent models which are kind of trying to do this thing. That whenever you are trying to do some kind of machine translation, whatever output you are trying to generate, right? Whatever output word you are trying to generate, you should look into some specific words in my input. You should not look into all possible words in my input. If you will do that, then you won't be getting a better translation. You need to just look into some specific words, right? So all these attention models try to learn this phenomena automatically. If you can learn this like mapping automatically, then you are kind of done. Right? So this is called attention model. Muppet means there are several, like hundreds of different ways in which you can create these kind of attention models. So all its variants are called Muppet model, attention Muppet model. It's not just a single kind of attention you can define. There are hundreds of different kind of attention that you can define. Right. So all different variants of attention can be defined as the Muppet model. Okay. Now a huge this is kind of very popular news. I hope you have seen it also, that a new natural language processing model was introduced, I think 2-3 months back, and that the name of that was GPT-3. I don't know if you've heard this name, GPT-3, right? And the idea was that it just requires few examples to generate a huge amount of text. So for example, as a human, you can enter a sentence, right? You can enter a sentence and then you ask the system to automatically generate text. For example, here, this sentence was given to the system. Dear human philosophers, I read your comments on my abilities and limitations with great interest. This was something that was given to the GPT-3 as an input, right? And then GPT-3 was asked to generate text automatically without any manual intervention, right? So it has generated what? Your questions are important, and I am glad to ask them. I would first like to say that I'm very happy to see that you take me seriously. That's why I wrote this letter in the first place. I'm not just an artifact that magically produces philosophical insights. Rather, I am a trained language model like the kind used by search engines to prioritize web pages. I have been trained on a vast quantity of source material, the collected works of greatest human philosopher that humanity has ever seen. Your words have inspired me, and I hope mine will do the same for you. Do you think this is a good text generation by a machine? This entire has been generated automatically, right? So this is the amount of investment that people are trying to make these days, right? So this is a real word system which has been trained, and what it takes, just a single sentence, right? Based on the single sentence, it has generated this, right? And if you see the generated paragraph, it looks very similar to what we had given. Sometimes even human cannot generate this quality of text. Right? So this is what people are trying to do these days. Okay. Now, how much money we have to spend to train GPT-3? So it has been estimated that around 12 million rupees will be required to train a system similar to GPT-3. Like if you want to create a system, you have to invest around $12 million to train a system like GPT-3. Right, and this table lists you like other models which are kind of very competitive and they have very similar performance like GPT-3, and their costing, how much cost they have, like how much cost one has to incur to train these models, how much CO2 emissions we have to make, how much cost we have to invest on, how much kilowatt power these systems require for training. So kilowatt power requirement because all these systems are trained on very high end GPUs. So for example, these CPUs are kind of very high end CPUs. V100 is very high end. Okay, so I hope you are kind of okay with the very recent development in natural language processing. There is still a lot of things which are still pending in natural language processing. And what problems these automatic systems have done is, like, all these systems have been trained on data, right? If your data is very biased, then these systems will also be very biased, isn't it? So there is no manual intervention, right? If your data is biased, these systems will also be very biased. So for example, bias towards gender. So what has been done is, like if you consider the first kind of models which we talked about, where like you want to find the similarity between two words based on the vector similarity, right? So man is very similar to computer programmer. Right? If you want to find the same similarity with the woman, it was found that woman is more similar to the homemaker, right? So man is similar to the computer programmer, but woman is similar to the homemaker. Isn't that a bias? Right? And this bias is present where? This bias is not grammar. This bias is actually present in the data set where the systems have been trained. So the problem is that the data set where the system has been trained, a lot of times the man is nearer to the computer programmer in the text, right? Whereas woman is most of the time present very near to the word like homemaker. That's the reason why the vectors have this kind of bias. Whenever people try to find the similarity between black and criminal, they find that the similarity is very between a black person and a criminal, right? Similarly, Caucasian, which is kind of like whitish people, they are kind of similar to the police. Again, this is a cultural bias. This is again a bias, right? Where you are kind of biased. So black people, not all black people are criminal, right? Not all white people are police. Again, this is a problem with the model. Similar models, similar problem is with the machine translation, right? For example, this this sentence, this is Turkish. O bir doctor, right? So in Turkish, O bir doctor means he or she is doctor. He or she is a doctor, right? It doesn't. It is not gender specific. O bir doctor means it could be anyone. It could be he. It could be she in doctor. When you convert this in English, you have to specify the gender. You have to specify the gender, whether it is going to be he or it is going to be she. So most of the machine translation systems will convert this into he is a doctor and not she is a doctor. So probabilistically, if this system would not have been biased, so half of the time this should have been converted to she is a doctor, half of the time this should have been converted to he is a doctor. Right? But it is actually not the case. And then there are a lot of other issues which like I'm skipping because in the interest of time. Okay, so that's the thing. Okay, so increasing merger with other fields, yes. Okay, so that's some of the issues with NLP, and it's not just like we are trying to solve problems in NLP using NLP algorithm. There are many other fields which where this field of NLP has been applied. So be it like knowledge graph. So in knowledge graph, we are kind of using natural language processing ideas. We are using natural language processing ideas in question answering, retrieval based question answering, right? We are using it in information retrieval. We are using this in knowledge based chatbot. In bio also, we are using a lot of concepts from NLP. For example, all these genes which are present in genes which we are converting them into vectors, right? So if two genes are similar, they will have their vectors similar. Similarly, we are doing it for proteins also. So for each protein, we have constructed a vector. If two proteins are similar, their vectors will be similar. Right now, like if two proteins are kind of interacting with each other, then also we can define the similarity, right? So if two proteins have a similar vector, we can say that yes, since these are interacting with each other, that's why they have a very similar vector. Okay, so all these things can be done. All these things can be done, and these people are trying to use all these different allied areas where they are trying to apply natural language processing things or like techniques. Okay, so that's all from my side where I have introduced with the natural language processing ideas. So before I move ahead, just let me know if you have any doubts here. I will happy to explain you those, and then I will just give you a brief introduction of what like how we have arranged the natural language processing course here at IIT Gandhinagar, how we are trying to evaluate students, right? And then I will just end my presentation. Let me know if you have any questions related to whatever I have covered in last 2.5.
Actually, whatever you have covered is very clear, but can I ask for a suggestion?
Yeah, sure, yes.
So, sir, can you brief us, can you give us an idea how should we guide students or what topics should we suggest to students for doing their UG projects?
Sure. So that I will cover in the next set of slides.
So, thank you.
Okay, so if there are no further questions, I will move to the next slide. And so this is the possible course content which I am currently not this semester. So this was the course that I covered in the last semester. And let us try to discuss like what's the possible course content in your case also. So in the beginning, since not everyone is well versed of how we can process the text, right? Text processing itself is a huge challenge, right? So we start with very basic text processing techniques like tokenization, stemming, corrections, and so on and so forth, right? So it's not just that we are teaching students about the theory of these different topics. We teach them how to program also. So how can you do tokenization by writing your own code? How you can perform tokenization by using some libraries like NLTK or SpaceY or so on and so forth. So by tokenization, I mean that you are given a sequence of characters, I should know what are different tokens, what are the different words. So for example, this is basic text processing, right? So this entire is a sequence of characters. Basic is one token, text is one token, processing is one token. Right? So for different languages, we can come up with different tokenization schemes. So that's the first component, and you should invest a lot amount of time on the first part, because people should know how to process text. Then only they can do the rest of the thing. And then, like once the text has been processed, most of the times we go with language modeling. So by language modeling means that how can we predict? So this task is very similar to the query recommendation, right? Yeah, I have typed something. I want to predict what next you are going to write. Right. So this is called language modeling task. So like so that's very interesting task in natural language modeling, in natural language processing. It's called language modeling, and here we want to predict what we are going to write next, right? And this entire modeling is very like the probabilistic. So what is the probability that the next word would be this? What is the probability that the next word would be this, and so forth, right? So we talk about n-gram, unigram, bigram, trigram models. We talk about smoothing technique. And then we work at a word level, as a word level, right? So that means that given a word, what are the some words with which this particular word has been constructed? For example, the word modeling. So this word modeling has been constructed into what? Is being constructed using what two words? Model, ing. Right. So all these constructions we study in morphology. So we start with basic tokenization. We move to the prediction of new words, and then we talk about how different words have been constructed. So morphology is all about that, right? Given a word, what are its constituents? Right. Part of speech tagging means given a word, whether this is a noun, whether this is a verb, this is adjective, like adverb, and so on and so forth. Can we do this task? Right. So both of these are at a word level. Move to the next part, that is called the syntax. Syntax means given a sentence, can we construct parse tree? Parse tree. So I hope you understand parse tree. What I mean by parse tree, right? So given a sentence, can we construct parse tree? Is this sentence syntactically correct or not? Is this sentence following the grammar of the language or not? Right. So that's the fourth component of this course. Fifth component is called distributional semantics. So distributional semantics means where we want to construct these vectors for a given word. Right, vector for the given word. So these things comes here in the distributional semantics. In case of lexical semantics, word sense disambiguation, we talk about like the meaning for a given word, right? And we use terms like word net. So word net are kind of a hierarchical tree structure where, like, at the top of it you have the entity, and at the bottom of it you have all the instances of the entity. For example, like if you have a word like mouse, the mouse will present at the bottom of the tree, and mouse can have multiple meanings, right? Mouse could be computer mouse, it could be the like the insect, the animal also, right? So based on what it is, you can climb into this hierarchy, right? And based on that, you can define its meaning. So lexical semantics is more about defining the meaning into this hierarchical structure. Distributional semantics is more about creating these vectors and then trying to find the relative meaning of two words. Right. So these are the main topics that we cover in natural language processing. Rest of the topics are kind of the tasks that we try to solve using these techniques. So for example, information extraction, I talked about that. Event extraction, relation extraction, summarization. I want to summarize the text. Then natural language generation. We have seen an example in the case of GPT-3. Then text classification. Text classification we do some kind of sentiment analysis, and then we do some kind of deep learning for NLP, where we talked about like systems like BERT. We talk about RNNs. We talk about LSTMs and so on and so forth. So if you are interested, you can look into this course website. So this course website is publicly available. Click on it, and it will take you to the course content that I have covered. It takes you to the lot of code programs that were created during this course, right? We have also talked about, we have also described here what kind of projects different students have taken, right? What kind of presentations they have made. Everything is here and publicly available. So I would always suggest that you look into this. And along with this, I would also like to discuss a very basic course evaluation that we did here, right? So unlike any other course that we used to have at IIT Gandhinagar, this course is kind of a very project driven, because students will be working on real world problems. It's not that they will be working on some hypothetical theoretical problems, right? So they will take some real world data and they will process that real world data, and then they will do something out of that real world data. So there was no end semester examination. In your case, I understand that in many of your case that you have to take the end semester examination, so you can like reduce the project components. You can reduce it to 30%, right? Keep 10% for the end semester examination. So since in our case end semester is not mandatory, so we didn't take the end semester examination. We only took project. So project was 40%, mid-semester examination 10%. There was a component of data set generation where people have to generate some new data, right? So new data means manually annotated data. So we had given them some data where like some reviews, for example, and they have to spend some time to label this data manually. And this contains 5%. So why this is required? Because they should understand the pain in generating the manually labeled data set. It's not very easy to generate a manually labeled data set. It's very easy to use the data set and create models, but it's very difficult to create the data set itself. And then there were like 4 assignments. Assignments are kind of very regular kind of assignment where based on class, whatever I'm covering in the class, and based on some programming assignment. So those were like 4 assignments, 5% each. I also take some surprise quizzes. So there were 3 in number, 5% each. Best 2 out of 3 will be considered were considered for the grade. Right. So these surprise quizzes were not announced any day, like during the semester they were taken. And then there were surprise attendance. So 10 surprise attendance in this entire 40-hour lecture duration of the course, 1% for each of this attendance whenever I have taken. Right. And the last was the online content creation. So this was something that is very novel that we thought of. Right. So the idea was that maybe like the users have to, the students have to create some online content, some novel online content, which means that maybe they have to create a GitHub page about some technique. So maybe like they can create a discussion about information retrieval or like information extraction. So for that they have to write a GitHub page. They have to write a blog, and the blog should be novel. It should not have been copied from already existing blog. They can also read some research paper in natural language processing, and they can just discuss that paper in their blog. That is also fine, right? So 5% marks for that. Do you have any comments here? Should I move to the next slide? Okay, fine, great. So apart from it, let me talk to you about the how we have done the logistics of these different projects. So a list of NLP project problems were supplied by the DS. There were some teaching assistants and they have constructed some NLP problems. So there were some groups, like the groups of 3 members were formed, and they were supplied with the problems beforehand, that these are some problems and you can select one of these problems. And this entire selection process was SPFS. So first come first serve. Who selects first will be assigned that particular problem. And every week there will be a meeting with the TA. So they don't have to meet me every week. They will have to meet the TA every week for half an hour or for an hour each team. And each project should have a demo system. So every project should have a demo system. At the end, they have to show that whatever they have done is working. Code and data sets must have been made public. Right. So these are some terms and the logistics of the project. And apart from it, let us try to look into the marks distribution and the timeline. So so there were so periodically we used to evaluate how is their process, how is their progress going on. So once they have selected their project, they have to write an abstract, and this abstract is kind of 500 sentence summary of what they are planning to do in the next 4 months. Right. And after 1 month, they have to give their first phase presentation, whatever is the update after writing their abstract. After 1 month, they have to give the phase second presentation that will carry 5% marks. And the final project evaluation in the final project evaluation, they have to present a poster, they have to give the demo, and they have to present the entire work that they have done in 3 minutes of presentation. PPT presentation, right? So that's called 3 minute madness. And finally, they have to submit a report, 10-page report. Okay, so this was all about project. So this entire thing carries 40%. 40% of the component was given to the project. Okay, and in my course, I followed these two books, these four books. The first one is the main book which we followed, the Speech and Natural Language Processing, an Introduction to Natural Language Processing, and this Speech Recognition and Computational Linguistics. This is by Zuravsky. Rest of these books are kind of useful, but this is the first one, Speech and Natural Language Processing. This book is very useful if people are trying to do some kind of deep learning, right? So this book is kind of very useful. It introduces you with the last one, the Ian Goodfellow, Yoshua Benju, and Oren Corwell. So this book is kind of covers all the basics of deep learning if people are interested. Right, and this book is this Natural Language Processing with Python. This is kind of a bit older book, 2009, but it is kind of the recent edition of this book is is very updated, and it helps in if you want to do natural language processing with Python. So very practical book, of course. Okay, so that's like a brief introduction to how I had taken. I used to take this course. It's a lot of stress on the project and not less on the theory of the course, right? And this is some of the members of my group. Most of them are currently graduated, so this is not the updated one. This is not the updated one. Most of them have graduated, and we do not have the recent photo because of the pandemic. And our group is called Computational Linguistic and Complex Social Network Group, and we mostly work on the problems of natural language processing, network science, and in addition with machine learning. Right. There are some very recent works from our group. One of them is called Gandhipedia. So I don't know if you have heard about the term, the portal Gandhipedia till now, but this is going to be launched soon by the Ministry of Culture, and this is its link. It will be live soon. It's not yet live. So this work has been done in collaboration with IIT Kharagpur. Along with that, these two are kind of very popular systems which we have created. So this system is it helps in understanding the COVID research, and it gives you the current statistics. It gives you it actually contains all research papers which have been written about COVID, right? So it's kind of very easy to just explore what papers have been written, what kind of genes they are talking about, what kind of proteins they are talking about, with what gene is interacting with what protein in what paper. So all these kind of interaction mechanisms have been you can just look into this link and you can find all these things. And last project is called NLP Explorer, where we have kind of indexed 50,000 natural language processing papers, and we do a lot of insightful things there, right? For example, what are the popular data sets which people have explored in these papers, right? What are the popular topics which people in NLP are right now working on, right? What are the popular authors and so on and so forth. So just look into this. For time being, I'm not going to explain this, but yes, this is again a very, very interesting portal which you can explore, right? And if you want to follow us or follow our group, these are the Twitter and the GitHub links, the GitHub handles, and this is my contact address. You can always contact me at my email address. That's my office address, Academic Block 4, address the office number 304, IIT Gandhinagar, Palace Camp, Gandhinagar, Gujarat, and that's my message. Thank you guys. Thanks a lot for listening.
Mayank sir, I just want to ask something other than
Yeah,
NLP.
sure.
Sir,
Yeah.
I have seen your profile. It's a very great profile, and you have got very good sponsor projects like this one, Gandhian. I think it is sponsored by Ministry of Culture and having more than 5 crores of a grant. Very good granted projects.
Yes,
Yeah,
yes,
yeah.
yes,
Sir,
yes.
at our college, S.P.I.T, we are having, we have introduced internships, various internships, like 6 months
Mm-hmm.
internships. Third year students can go from next year in the third year, when they'll be in third year, they can go for semester long internship, like 6 months. And currently,
Mm-hmm.
final year also, they are having internships. Some short term internships are also there. So, if our students
Mm-hmm.
wants to work with you, what are the possibilities
Mm-hmm.
IIT Gandhinagar and your group offers? What is the mechanism if they want to work?
Yes,
Because
yes.
these are very good,
So, here,
quality students we get.
yeah. So here actually, there is a very standard mechanism for like for all formal internships. So what you can suggest is your students can look for this thing. This is called SRIP program at IIT Gandhinagar.
Okay,
Summer research
okay,
program. So like this is a very standard program where like all faculties, this is like institute wide, so all faculties will float some projects, and students will get some funded internship. They will be paid for this internship also. Right. But individually, it's kind of very dependent on the different faculties. So I floated around two last year. So like every faculty will float. So there will be more than like 120 projects, something like that. So almost every faculty will float some project.
okay. So normally,
Yeah.
when this formal mechanism when it starts, generally when students are
I
supposed to
think
apply for the
I,
internships.
I think it starts early next year. So it's kind of like January or Feb.
Acha, okay, okay, okay,
They will get a time period for like 15 days or so to apply, and then 50, I think it is more than 15 days, and then people can apply. They will be shortlisted, they will be interviewed, and then they will be offered position.
okay, okay. Sir. Thank you, sir. Any other
Yeah,
questions?
thanks a lot.
Participants, any other questions you would like to hear? Would like to discuss with sir?
So before like people can ask me questions, there is a event which we are organizing along with IIT Kharagpur. It's called Indo ML. Uh, I would suggest if you can register for this event. This is a very interesting event. It's free and very good set of speakers who will be attending this event. So I would always suggest that you like register for it, and details will be sent to you as soon as like we finalize all the participants. So it's called Indo ML.
Indo ML. Okay, sir.
You can participate. You can float it among your students. Your students can also participate. All research students can, everyone ideally can participate. Even the UG students can participate. Just go through the speaker list. It's amazing. Like you will find speakers from MIT, Stanford, Oxford, everywhere, and almost all good quality, or like very popular companies.
Okay. Renuka madam,
Yes, actually I
I
got
think this
disconnected.
you
Yeah,
are
yeah, there was some internet issue at my side. So I hope I'm audible enough now.
yes, yes, you are
Yes,
audible.
yes,
I
yes.
don't
Yeah,
think
yeah.
there are any questions. Any questions? Last call, any questions? No, I don't think there are questions. Okay. Okay, Renuka madam, you can go ahead.
Okay.
I'll just present.
So thank you very much for very informative session, sir. So from your session, I got reminded about this quote: "The teacher who indeed wise does not bid you to enter the house of his wisdom, but rather leads you to the threshold of your mind." So thank you once again for taking the time from your busy schedule and teaching us by showcasing very good examples on information extraction, sentimental analysis, chatbots, lexical and syntactic ambiguity, why NLP is hard, conceptual embedding, attention to mupate models, ethics in NLP, and giving us a possible course content with excellent applications in place along with the course and project evaluation scheme. So thank you once again for an excellent session, sir. Please accept this virtual memento from our side, from the organizing committee.
Yeah, thank you, Rinikoji. Thanks for that. Yeah, thank you.
Thank you very much, sir.
Yeah, thanks a lot. Yeah, thanks.
So
Thank you,
Ratu sir,
everyone.
if you have anything
Thanks a
to
lot
say,
for.
yeah.
Yeah, nothing. Mayank sir, I have sent you another invite today. That is for our third FDP, next FDP. You will be speaker in there. No? One session you are going to.
Yes. Sure.
Yeah.
I will look into that. Yeah.
Yeah, sir. Yeah. Okay. Okay. So thank you very much,
Okay.
sir.
Thank you, sir.
Thanks, sir. Okay.
Thank you. Thanks a lot.
So thank you, participants. Thanks a lot. We are going to meet again evening, uh, 5 o'clock. Rocky sir will be there. Hands-on session. So please join on time. Okay. Thank you very much. Thanks a lot. So I'll be closing this meeting now.
Thank you, everyone.